welcome to you all listening in from and watching from across Europe and even beyond. Welcome to this PlastiCircle Final Forum, which of course today the theme of this forum is disruptive technologies for the circularity of packaging waste. Now this is of course brought to you by the PlastiCircle European Horizon 2020 project. This project started life in 2017, some 4 years ago, but of course it's one of a clutch of strategic European initiatives that aims to rethink the way we treat plastic packaging waste, and indeed it's been rolling out innovations across the value chain, and indeed in 3 European cities, Valencia, Utrecht and Alba Iulia. My name is Matthew Carey, I'm the moderator today, and first of all I would just like to run through a couple of housekeeping rules with you. And now of course if you're on social media, then the Twitter and LinkedIn or even Facebook hashtag is PlastiCircle Final Forum, so please be sure to keep up to speed via social media. Now, if we move on to the rules of the event, some housekeeping, just so you know, from 9 AM to 12, attendees will be able to ask their questions on the chat. Now, we will try to answer as many questions as possible via the chat function this morning, but of course we are pressed for time and there are few opportunities to ask questions. So we'll select some of the more pertinent questions and we'll put them to the speakers. And there will be a couple of opportunities for you to do that this morning. In the afternoon session, we will have a round table. So that is between 2:30 and 3:10, and there you'll have opportunities to pose your questions to the speakers live. Finally, let's have a quick look at the programme for today. Now, you'll already have access to this somewhere, I'm assuming, in your documents, but if you would like to, please take note that our coffee break is at 10:15 to 10:30. And then we also have a lunch break from 12 o'clock midday to 1 o'clock, and after 1 o'clock we'll continue with the program, and we are due to finish at 3 o'clock sharp. So I would be grateful if you do have questions, if you could be very brief and succinct when you pose those questions. Now, without further ado, I would like to open the floor to our first speaker of the day, who is the technical director of ITENE, who of course is the lead partner in the PlastiCircle project. Carmen has more than 20 years of research and development and innovation experience, and leads the technical activities within the ITENE group. So, without further ado, let's proceed with today's conference. And Carmen, the floor is yours.
Okay, thank you very much, Matthew, and welcome to the Plastic Final Forum, organized by ITENE Research Center in collaboration with KIM-BCN, Troplast, and ICLEI, and with the support of EcoEmbes and Plastics Europe. As many of you already know, the PlastiCircle project, funded by the Horizon 2020 program, will come to an end next month after 4 years of intense work to rethink the packaging waste cycle and transform it into a circular model aligned with the European Union strategy. As coordinators of this 20 partner consortium, we want to thank all the speakers and attendees for making this final forum real. In total, 335 attendees from 39 countries have registered for this event, where we will show the technologies and new products developed in PlastiCircle, as well as the results of the three pilot projects. In this context, let me briefly present ITENE and how it's working in a wide range of R&D initiatives with an international scope and aligned with the European strategy on circular economy. Okay, I think it's working now. As you know, we are a research organization, a research center specialized in circular economy, safety and security, and sustainable mobility. We have more than 25-year experience creating technological solutions through research and innovation projects for companies. Here we have some sectors where we work with. through innovation projects. We work for raw manufacturers, packaging materials producers, packaging manufacturers, food and beverages producers, cosmetics, pharmaceutical products, chemical products, electronics and capital goods, sustainable and connected mobility, transport, distribution and e-commerce, and waste management. Well, if we work on circular economy and efficiency, well, we are focusing the development of efficient packaging. We also work for the circular economy and sustainability in a wide way. We are focused also in sustainable mobility and in safety and security in products and processes. Well, I can go ahead. We try to work just around all the distribution change, distribution of product change, and if since we have a product or a material we want to use for a new packaging, until this material comes into a waste, and we have to do the treatment to get it again into a new material for packaging options or to other options. So we develop new packaging materials. We can also measure and we can determine the environmental impact of packaging. We can also do the assessment of the compostability, the recyclability assessment. We also work in the development of recycling technologies and the waste valorization processes. Okay, as I said before, we have an integrated supply chain overview, and we do innovation all around this chain. So here we have some recycling technologies. When we work on these areas, what we try to do is to start in the collection process to ahead transport, sorting, and recycling technologies. Well, we work a lot in European projects since many years. Here you have some of them as PlastiCircle, of course, also Excalibur, Merlin, suppliers, and we have other regional support to develop all these innovation and research initiatives. So here we have some other examples. In Cycle, the purple Zero Wizard, Celsi are European projects, and also Pulp Action, Aurimax, Prepare 3D, Hoop, and Sherpack. And well, here we have some numbers about our experience and participation in European projects. In the 2020 Horizon program, we are working in 34 projects with a returns for over 16 million euros. There we were in 8 of them as coordinators and 26 as participants. And if we see all the European calls since 2008 until 2020, we were involved in more than 97 projects with our returns for ITENE of more than 30 million euros. And we were coordinating 17 of them. Okay, so to finalize my introduction, I would like to point out that we at ITENE are very proud of the great work jointly carried out along these 4 years. And we are sure that PlastiCircle is going to be considered as a success story in this transmission of the circular economy. Thank you very much.
Thank you very much, Carmen, for that very succinct presentation. Very helpful to receive an overview of what ITENE has brought to the table over a number of years now. Now, if we could proceed to an all-important presentation, which is, of course, the new paradigm for the circularity of plastics, and this is where we really get into the program of the day. We're very lucky to be joined by a friend and colleague, César Aliaga, who of course is the PlastiCircle coordinator, and with ITENE, he is the head of the Packaging and Circular Economy Unit. César, we're delighted to hear from you, so please, the floor is yours.
Thank you, Mathieu, and good morning to everyone. So just one moment to place the presentation. Okay, so thank you very much, Mathieu, for your presentation, and welcome to this final forum. We are really happy to have you all connected today in this big event, but not physical, of course, but anyways, a very big event. So thank you for that. So in this introduction, I will briefly introduce the PlastiCircle project, but then we will have the whole day in order to analyze step by step, point by point, all the technologies, all the work that we have done during those 4 years before the end of the project that will be next month. So I will start with the problem on the plastic and packaging. As you can see in the screen, around 27 million tons are generated per year, and only 31.1% is recycled. So that generates a very high impact, both economics and environmental. In the economical point of view, around 11 billion euros, because we are placing most of this material in the landfill and it has a cost, and also we are not using we are using virgin plastics instead of using this recycled plastic, so it costs this amount of money. Also, environmentally speaking, it has a very high impact, around 25 million tons of CO2 per year. So packaging has a lot to say, because as you can see in the diagram, it has a lot, a high percentage of influence in the plastic industry. So the reasons that we found of that was the low quantities collected, the low quality, because sometimes it's mixed, and also the low added value applications. So that was the picture, let's say, before PlastiCircle. So we organized this project because we really think that we could do some changes on this, especially improving the collection, the transport, the sorting and recycling. So collect more and with more quality, then transport in a more efficient way, also sort in order to get materials with a higher potential of valorization, and finally recycling. So developing new added value products, because it's the only way to make the system or the value chain to work, making added value applications. So we started with this project. We are participating 20 partners all around Europe. We have research institutes, we have trade associations, recyclers, waste management companies, and also municipalities, as you can see in the map. We are placed all around Europe. And going to the technologies, as I mentioned before, we are doing technologies in the project on collection, transport, sorting, and recycling. We have finished all the technologies. They are ready now. So starting with collection, we have developed smart containers that are able to identify citizens and also to know how are they separating at home. And also this information is important in order to compensate. So it gives information in order to make this pay-as-you-throw, this compensation to citizens. Then in the second part of the project, transport, we will see all those technologies more in detail in several presentations afterwards. Anyways, in transport, we were working in filling level measurement to know how or to which level are the containers filled. And this information led us to plan product optimization measures. This is to say that only containers with a certain level of waste were collected. So that makes a lot of improvements in the transport and the collection costs. Then in the third part of the project, sorting, we have been developing new sorting technologies in order to separate plastics that currently or before PlastiCircle have some problems to be separated. For instance, films, and in fact we have developed one film stabilization conveyor that makes possible to separate plastics and films in a better way. And finally, regarding recycling, as I mentioned before, is one of the most important parts of the project, because this is the final value chain of the plastics. So we have been working with different industries in order to develop new products like foam boards, automotive parts, bituminous roofing membranes, garbage bags, and retention grids. We will speak a lot about that as well. So here you have the pilot cities. Those are the work done there was very important, because we tested there all the technologies that were implemented in the project. So thank you to Alba Iulia, also thank you to Valencia and Utrecht, because those 3 cities were really involved in the project, and they were really helping the project to implement and to validate the technologies. So which are the benefits of the project? we think that we have three kinds of benefits. First of all, technological, because we have developed, of course, new collection, transport, and sorting technologies. Also, innovative recycled products, so technological benefit is clear. Then social and economic, because we have developed new businesses. Also, we think that in the future, those new businesses will be able to develop new companies. So we are making or trying to make or to improve the competitiveness of the industries in Europe. And also, it gets more recycled materials in the EU market. So somehow, the European Union will be more, or will have less dependence from the resources from outside our countries, no? Because with those materials, we will be more, we have raw materials. And finally, also environmental benefits, because those technologies will help to reduce landfilling, to reduce incineration, and also to reduce the use of virgin material. So benefits in three axes. So where do we stand? So we are really at the end of the project. We have already developed all the technologies on collection, transport, sorting, and recycling. And now we are working on dissemination, as the event we have today, and also on exploitation, because we really want to reach the market. So the objective also of today is to achieve or to get as much partners as possible in order to be able to reach the market and to exploit our technologies. And what are our technologies? So here you have like a brief summary. On collection, we have the smart container. On transport, we have the route optimization and vehicle driving. Sorting, we have the film stabilizing plastic sorter. And on recycling, we have, of course, the final products that are the foam boards, automatic parts, roofing membranes, plastic bags, and detection wheels. So we really want, or we really expect to exploit those technologies in the market as soon as possible. So you can also get involved to our initiative, to our project. You can visit our webpage. Also, you can follow us on Twitter. You can also contact with us, maybe make some agreements, some contacts with our partners. And also, you have here the project video that is amazing, and it's really a summary of 3 minutes about what we have been doing in the project during those 4 years. So thank you very much. I hope that you will enjoy our final forum, and we are here to help you in any question, in anything you want to share with us. Thank you very much.
Thank you very much. Thank you very much, César, for that very, very succinct overview, and really important, of course, to see very clearly the innovations that are being brought to market, and of course that is something which we'll delve into in more detail in a few minutes. Now, actually, to hand over to the next speaker, because we need to place this in the broader European context, of course, and to discover how the European Commission and a number of European Union agencies are indeed supporting projects such as PlastiCircle. And for that, we're absolutely delighted to welcome today 2 officials from the European Commission. The first of whom is Yannis Kougoulis, who is a project officer with the European Commission, and he's briefly going to run us through the circular economy in the European Union, and more specifically the role of Horizon 20 and Horizon Europe, because this is of course the basis for the PlastiCircle project and many other projects like it. Yannis, the floor is yours.
Yes, hello, good morning everyone. I don't know how I can share my presentation. Okay, thank you. 1 minute. Okay, so good morning everyone. Just if you could, someone could confirm me that you could see my screen.
Yes, we can, Yannis. You're good to go.
Okay, thank you very much. So I have the opportunity to share with you the program of the funding programs of and make a little bit a description of back in time of the Horizon 2020 program that finished, and the Horizon Europe came on and followed it. Back in 2016, at that time, the political momentum of circular economy came in. Horizon 2020 was one of the key programs funding innovation actions and research and innovation actions. Only in 2016 and 2017, there were 650 million euros channeled to grant and foster innovation in order to prove the ground, the economic, and environmental and social sustainability of circular economy. Later, in 2017, in June, it was the call where PlastiCircle was also funded. With 8 innovations actions in that call were funded together with PlastiCircle. Most of the projects, many people are familiar: Zero Bright, Park, Police, EcoPulp, Paper Chain Systemic, and Fiber use together with PlastiCircle. They got an overall budget of 68 million euros, and the thematic was to design for circular value and supply chains. We can see PlastiCircle is a typical project of a circular economy which aims to tackle also collection, transport, sorting, valorization in value-added products, and upcycling. So there are typical the elements of circular economy where the projects should aim and the innovation should target. I will not describe now what is the PlastiCircle as this was described just a minute ago. Just to mention that the project is or has a budget of 8.6 million euros and a duration of 4 years. And now we are in the lucky position to see the many positive outcomes of it. Horizon 2020 working plan continuing in 2018 and 2020. The last call was on connected economic and environmental gains, the circular economy. And the last round of project of Horizon 2020 will kick off in 1st of June. And they are also in many of them, they are also in the thematic of plastics and circularity. As many of you are familiar, most of you are familiar, the political momentum and the political landscape has changed. Now we are talking about the European Green Deal. We are not having only a circular economy, but circular economy is one pillar of the European Green Deal. And now that we are talking about the future, I would like to give the floor to my colleague, Hans Christian Eber from Research and Innovation Director General, so that he could continue the presentation on the upcoming funding opportunities and how circular economy is embedded in the new Horizon Europe program.
Thanks very much. I think you can see and hear me.
Yes, thank you very much. And I'm happy to ask what you.
Can you keep the presentation on the screen? Well, I think that would be the easiest. We just go on with your presentation, right?
So I keep this presentation, this slide, Hans.
Yeah. Okay, and we go to the next slide. Wonderful. Many thanks for this introduction. You focused on the changes. I would like to focus on the continuity, because why am I showing this slide? Because I think we had lots of position papers and strategic information where we already rolled out what we wanted as the European Commission, as the European Union. There we talk about circularity, but what you see here is that maybe the focus was not always that clear. While some of these documents have a specific focus on material streams and target these from a pollution or waste angle, we were then moving on to a more resource-oriented approach, and only lately we were addressing circular economy as part of the solution, or maybe one of the key enablers for dealing with climate change, for climate change mitigation, and for climate neutrality. So in a way, I have a strange thing on my screen now. Okay, it's all right. In a way, the European Green Deal sums up what we wrote in the plastic strategy in the first Circular Economy Action Plan, and goes back to that aggregate level that we had in the UN's Sustainable Development Goals. And I would see the Horizon Europe work program or a framework program and the Circular Economy Action Plan of 2020 as part of the implementation, or as part of the commitment that we took with the Green Deal. So for me, the important thing is that this doesn't come as an epiphany. It doesn't come out of the blue. It's a continuation of what we already did before. It gets a new dimension now post-COVID, where we see that we need to strengthen our recovery and resilience potential, and we also think that the actions that we want to initiate under the mandate of the Green Deal will contribute to recovery and resilience from crisis. The key point for me is that we move from a pollution and waste and end-of-pipe oriented approach to a more cradle focused and resource oriented approach, and to a more integrated approach that addresses, targets the climate problem, but also socio-economic impacts of change, of this transition. I spend a lot of time on this slide, but I think this context is very important. But let's go to the next one, where I want to explain the context of Horizon Europe. So if we see Horizon Europe as part of the implementation of the Green Deal, what does the structure tell us about this? Horizon Europe is the next framework program for research and innovation after Horizon 2020. But what has changed? Well, we have a slightly different breakdown. You have several clusters. There's health, culture, security, digital. Digital is together with industry, climate. And there's the cluster 6, on which I'm working, which has sort of a nature focus. Environment is together with natural resources, with food, bioeconomy. Well, that's a good thing and a bad thing. I mean, all the other clusters also about environment, so we still have a bit of fragmentation, but one of the good things would be that circular economy and bioeconomy are together in one cluster, and that we don't ignore or neglect the problems that we have with certain forms of production, say in agriculture. The cluster 6 paradigm is very outspoken and very clear. It says transformative change of the EU economy and society, reducing the environmental degradation, better management of natural resources, and it says it serves the EU's climate objectives, meaning the 2050 target. So this acknowledges for the first time in a high-level paper that circular economy and bioeconomy are main contributors to climate change mitigation. There's another breakdown going down in the category under cluster 6. There are several destinations, and the one I'm working on and this matches also the portfolio of my unit in DGRTD is circular economy and bioactivity and bioeconomy sectors. Again, it looks a bit fragmented because zero pollution, for example, is in another destination. But what we learned is that with the co-creation process, that was the way how we drafted the first work program, we can target or resolve the problems that this fragmentation might create. So you have circular economy not only in cluster 6 destination 3, you also have it in the digital, meaning the industry sector in cluster 4. And you might, for example, have topics on chemicals in cluster 3, no, in cluster 1 on health. So, but you shouldn't worry about it about this because the coordination and cooperation level is very high and much higher than it was under Horizon 2020. Cluster 4, which is not my business, but I mentioned it nonetheless. You have topics on circularity hubs, industrial symbiosis. These will be research and innovation actions, and you have a focus on solid waste in urban environments. There will be an innovation action. You see that the focus there is on industrial processes and on materials. That's a bit different from what we are doing, what we are planning to do in our destination 3, where we talk more about systemic approaches. But in any case, there will be clustering activities. If you know the procedure for funding projects and you're all experts, then you know what this means. So there will be close cooperation between us and the industry people. Let's go to the next slide, zooming in on circularity. Now, this is what we will continue to do. I mean, the implementation will be with the agencies, but to a large part. But this is what we do in my unit, and there you see that's sort of a triple approach. You have the scientific aspects of circular economy, meaning data collection and interpretation, impacts of circularity. You have the traditional focus on material streams, mainly those that are mentioned in the Circular Economy Action Plan. And you have, as a third pillar, a territorial approach, which is a relatively new concept. You have additional topics on bio-based materials, and there we try to increase the coherence between bio-based topics and circular topics, meaning increasing the circularity in the bioeconomy and also tapping the potential of biomaterials for the circular economy. Now, how will these projects look? There will be several calls, and they will be mainly innovation actions with relatively high TRL, even up to 8. I would say per line here on this slide, you have calls for around 20 million, unless this still gets changed, but I think it's unlikely, which would allow the funding of, say, 3 projects each. In addition to that, you will have topics on construction and plastics, again in cluster 4 with our industry colleagues, with a strong focus on industrial processes. So this would be complementary to what we are doing. On the next slide, I want to go back to I call it horizon to horizon. I want to go back to two older calls, because I think while we have a few really novel approaches in Horizon Europe, I think there's also some continuity. Because this was one call that I wrote, the upper one, which was part of the last work program, the 2020 work program of Horizon 2020. Sorry. And there you see that the focus already changes from simple interventions focusing on technology to a more integrated and scientific approach. This is an innovation action with a TRL up to 7 and 50 million, which allows the funding of 2 projects. And below you see that's sort of a missing link. That's something that connects Horizon 2020 and Horizon Europe, because that's the first project that supports the territorial deployment of circular economy. It's the nucleus of the CCRI, the Circular Cities and Regions Initiative. It's called Demonstration of Systemic Solutions for the Territorial Deployment. And this really has a 100% local and regional scale, and should cover all sorts of possible streams, including water, energy, waste, materials, housing, whatever is important for a local economy. The call is already closed, so this is in the evaluation process now. That's an innovation action with a TRL 6 to 7. And it's quite some money. It's a 60 million project, and that's only the kickoff of the CCRI initiative. So if we go to the next slide, the territorial solutions. Building on this Green Deal, we recently published published the terms of reference for the CCRI Coordination and Support Office, a 5 million project, and there I'm on the evaluation team for the tenders, and that's what we are doing right now, selecting the winner, and this will contribute to the deployment of these territorial solutions, because there we want to create a core team that really advises cities that have problems, that have ideas for circularity. That this team will select pilot projects and also spread information. And building on this, there are several calls on CCRI in Horizon Europe. And there, that's sort of a third pillar where we try to improve the coordination with other organizations that are strong in circularity, say the European Investment Bank or OECD circularity team. So there are several targeted actions, and all these actions together will create a bigger picture and really bring the territorial deployment of circular solutions to a new level. So you will still have plenty of projects, say, on plastics. So even if we want to move along the value chain and try to support solutions for sustainable design and and want to see waste prevention measures and strengthen local repair and dematerialization and service business models, we are fully aware that we cannot do without traditional recycling. So there will always be a slot for technical solutions. But you see that the picture is changing a bit. But in any case, what is clear, what I can reassure you, is that circular economy is really strong in this work program and is identified and addressed as one of the key levers, one of the key instruments for climate change mitigation, for societal resilience, for socioeconomic recovery, and that we really want to take circularity to the next level. So that would be my introduction. And I think it was a bit too long, but it's still okay.
Okay, thank you very much, Hans Christian, and thank you very much to Yanis as well. Really important to receive a macro overview, of course, especially in the Green Deal paradigm, in which we live, and of course, this innovative technologies are a big part of the European Commission's circular economy efforts. In that regard, we'll move on immediately to three very important presentations, and after those, you will have time to ask questions. So I would ask that Mireia Calvo of ITENE, Ricardo Camarena of SAV, and Luis Segui, who's the Managing Director of Peak Visa, come to the floor. And we also had very quickly a question from Diego in the audience. Don't worry, Diego, and to all of you, because all the contents and all the presentations will be shared afterwards via email, so you will have all the necessary information. So, without further ado, please, Mireia, the floor is yours.
Okay. Hello, good morning, everyone. Can you Can you see my screen?
Yes, we can, Mireia. All yours.
Thank you. So I am Mireia Calvo, and I am going to explain you the technologies implemented by PlastiCircle project in the collection part. Okay, so we will go through the PlastiCircle solution, focusing on the collection and the steps of the system developed by PlastiCircle, that is first registration, second identification, the smart container, the individual characterization, and finally the compensation. So this slide has been shown by our coordinator, Cesar, and as he said, PlastiCircle has four main pillars, and we will focus on the collection. That the main objective is to increase the collection rates of PlastiCircle packaging waste sorted at home. The collection part has been tested in Alba Iulia and Valencia cities. So now we are going to see the reward system, the smart containers that has three main technologies: the identification model, the communication, and the filling level sensor. Then the characterization protocol and the compensation to citizens. Here you can see the summary of the reward system. This image will be along all the presentation in order to you can follow the system that PlastiCircle have developed. The main objective is to compensate the citizens based on the quality of the packaging waste produced, increasing the quality of this packaging waste. So the first step is the registration of the citizens, then the identification through an NFC card and a keyring. This NFC card should be used in the smart containers. Then once the plastic packaging waste bag is thrown away in the container, these bags are characterized with the characterization protocol and analyzed, and then is the compensation part to the citizen. So the first step, that is the registration.
For this step, all the cities has done a big communication campaign in order to engage the citizens to participate in the pilot activity and in the PlastiCircle project. And during the registration of the citizens, the users that will participate obtain the NFC card with the PlastiCircle logo and the keyring that you can see in the screen. Once they have this identification systems or cards, they can use them in the smart container that you can see the smart containers in the screen now. The value proposition of these containers is that any kind of container can be smart by attaching the identification module that you can see on the right side of the containers. These identification modules are a labeling system. So the users should press on the button, then they use the keyring or the NFC card through the red point, and a label is dispensed, and this label should be stick on the packaging waste bag. With this technology, we are linking this bag with the citizen, and we can identify and link the bag with this person. We had some challenges, as you can see on the right, that some malfunctions of the labeling system during the pilot activity at the beginning, and some re-infiltrations, but everything has been fixed and solved during the pilot activity, and everything go well finally. Then this identification module should need the support of some communication system that are the devices that you can see on the left. These devices are distributed along all the pilot area, and the identification module communicates with them through LoRa. And they are registering the identification number of the user, the label code, the date and time that this container is used, the number of the identification device, and also which node is sending that information. All the information is collected in Iot Platform that collects all the information of the smart containers, of the compensation reward system, all the points of the citizens, but also the transport developments and the transport results. Some of the challenges were that as we are testing this communication with LoRa, at the beginning we had some difficulties in the pilot area, but we'll solve it, increasing the number of nodes in the pilot area. Now, the last technology, we talk about the identification module, about the communication of this smart container with the Iot platform in order to collect all the needed information. Now is the turn of the filling level sensor. We use commercial filling level sensors that were implemented in 25 containers. The filling level sensors are communicated by GPRS, and these sensors send data about the level of filling of the containers every hour. At the beginning, it was every 8 hours, but this was improved, and every hour the filling level sensor is sent. What we saw is that there are 3 types of containers, depending on the use of the container: high use of containers, medium use, and low use, as you can see in the graph on the left. This information is very useful and fit the optimization route in the part of transport that you will see later. Some of the challenges that we had with the filling level sensor were rain filtration, but everything was worked well. Now we talk about the registration of the citizens, about how the citizens can be identified in the smart containers. We see the smart containers, we saw the smart containers and the 3 technologies, the identification module, the communication system, and the filling level sensor. Now we are going to see the characterization protocol. Once the citizen has thrown away the bag inside the container, what happened later? So these bags are chosen randomly from the container, and these bags are analyzed. The first step is to see if the bag is full or not. Then these bags are open, and we will analyze the content inside these bags. What we are seeing here is if the content of the bag and the items that are inside are packaging waste or there is any unwanted material. For example, in the picture, you can see that the item number 1 is unwanted material because it is not plastic packaging waste. We are seeing if the packaging is empty or not. We are seeing if the packaging is stacked or not, and if the packaging is compacted. If the bag is full, if there is no packaging waste, if the packaging is empty, if the packaging is not stacked, and if the packaging is compacted, this user will obtain the maximum number of points. You can see 2 tables, and there is some of the results that we have obtained in Valencia on the left and Alba Iulia on the right. And you can see that the non-users or the pre-pilot users, the analysis that we did before starting the pilot, are worse numbers than the people that participate in the pilot activity. So the users participating in PlastiCircle obtain better quality of the packaging waste sorted at home. That was the objective that we had. What challenge we had here? It was the replicability. This characterization protocol was done manually, and it can be replicated to big cities and big areas. But we thought in a solution for this, that is to make this individual characterization automatically. You can see an image on the left that is in the entrance of the replicability recycling plant. Sorry, is the first point in a recycling plant. So the idea is to include a small sub-belt loop at the beginning of the plant, capable to read the barcode of the bag, open this bag, and with visual techniques, identify the items inside the bag and assign these items to the barcode read, so with the user. And then once these items are identified, go again to the main loop in the recycling plant to continue the process as it is now. Now here you can see some escort activities. We have talked about the characterization protocol and the use of the containers, but we launched also some surveys that the participants can get more points, and social media challenges and webinars and trainings that the citizens participating in the pilot can get more points. And then we have the compensation and these points that can be exchanged by rewards, and some of them are the ones that you are seeing now. And the 3 best participants obtain an electric scooter. You can see on the left some of the better results that we have obtained by one citizen, with the weekly participation, the characterization protocol, the webinars and trainings, and the social media and the surveys answered. And that's all from my side. Thank you very much.
Thank you very much, Mireia. And if we could just ask Ricardo to come in with a few comments. Please be quick, Ricardo. Thank you.
Okay, let me show my screen. Can you see my screen? Just to confirm that I can start.
We certainly can, Ricardo. The floor is yours.
Okay, thank you. So Mireia just explained the collection part, so I'm going to explain the transport part. Is the part that precedes the collection part. So let's start with the transport part that comprises the eco-driving and auto optimization technology. Okay, so these are the objectives of the transport part. The first one is optimize the transport process packaging waste, but at the same time, this objective can be applied to other waste fractions such as organic, paper, and so on. We also have the next objective: develop algorithms for route optimization and guidelines for efficiency. The next step is to develop an eco-driving system. We also have integrate the information received from the different source of data. Let me see if we can change this. Okay. As a last objective, we also have integrate information received from the different sources of data. Okay, so these are the results that we are going to talk about. The route optimization based in a 511 sensor installed in all the containers of the sample of the pilot. We will also talk about the eco-driving guidance, monitoring the truck and setting alarms to guide the driver. And last but not least, the IoT platform. This IoT platform will receive all the data from the experimental pilot about the collection and transport that will be studied and analyzed, all of this data. Okay, so how the system works. It starts with a canvas reader. Newest vehicles nowadays have an OBD2 port. Okay, there are OBD2 ports very cheap that can read the data from the track to the application. But this device is not compatible with all the vehicles. Then, if the OBD2 reader is not compatible, we will use a specific canvas. We will use a specific canvas reader for the vehicle. Then the reader, either if it's a canvas or an OBD2 reader, like this example, sends the data via Bluetooth to the application, to the Android application. This way, you can get all the data from the tracks, as for example, speed, revolutions per minute, like braking, accelerating. This application will send the data via 3G to the cloud of the IoT platform located in the facilities. Okay. Okay. First, this application has an algorithm that has established like driving parameters. If the driver exceeds these parameters, like figurated in the application, an alarm will set and will sound and will warn the driver and invite him to correct the anomaly. For example, if the driver exceeds the ideal speed or revolutions per minute of a certain point of the route, the application will let the driver know through a beep alarm. Okay, so these are the parameters that I told you guys before that are measured by the application's algorithm. All these obviously with the help of a GPS location that will have the truck that will help us to know the position of the truck in a certain given point of time. These are the data: speed, revolutions per minute, engine load, and fuel consumption. Here, for example, we can see the conditions for excessive idling. Excessive idling is basically when you have when the engine is on, but you are not driving, so you are stopped. So we can see here the conditions for excessive idling and therefore alarm when the car is stopped. So speed equal to 0 and revolutions per minute lower than 800 during more than 60 seconds. So if all those three conditions take place, there's a peak alarm, for example. Okay. So we can detect from the data where a container was emptied. To know the location where a container was emptied, we looked at the parameters of the revolutions and speed that a truck experiences each time it is emptying a container. Velocity equal to 0 and revolutions per minute, it's more than 900. So that means a car is emptying a container during more than 30 seconds. When these three conditions took place, a container was emptied. So here we can see if we compare both maps, the map in the left show the locations of the containers and the map in the right where the system detected that a container was empty. So you can see are obviously similar. And if we compare both maps, we can see that also that the locations match very well. Then in this way we can detect whether a container without an additional sensor in the truck or in the container, so we can see similarity. Okay. So in the IoT platforms, with all the data, we can see graphs of speed and revolutions in the function of time. This scale is longer, so that means the difference. So in function of the time, speed and revolutions per minute, in function of the time and where the alarms we produced. Okay, so this is the screen of the application. Here you can see the different alarms shown in the Android application. The driver doesn't need to see the screen of the application. He or she just needs to listen to the beep alarm. So the type of alarms that are shown are, like, for example, speed, overspeeding, revolutions per minute, excessive idling, braking, or like hard braking or hard acceleration. So in this slide, you can see the improvement in driving from a hiding mode without an alarm compared to the mode with sound alarms. So these alarms make the driver correct his driving mode, obviously. As a result, in the pilots, we experienced the consumption of fuel was reduced by 11%. So that's a good indicator, and also the speed in some routes, not in all of them, and not the arithmetical median, just the maximum point of speed in certain roads, were reduced to 90 to 81 kilometers per hour. So that's it. We also have a reduction of excessive idling, the thing that I explained before, by 51%. So that's also a good indicator. Okay, so in addition, a field level sensor was installed in each container. Okay, this belongs to the route optimization part. Okay, so in order to offer a customized and optimized route according to the filing speed of each container. The following slide shows an example of an optimized route. This route will be marked on the map and will guide the driver all the time. So we can see here the optimized route. It was like 3 optimized routes. This is the third route that we have here, and this route will be marked on the map, and this is the screen of the application that the truck driver will see, and this screen will this maps application will guide the driver. Okay, so this slide is the most interesting slide. Here you can see a comparison of the results obtained in both pilots of the 2 cities, Valencia and Alba Iulia, with the implementations of the 2 technologies, route optimization plus EcoDrive. Indicators of improvement are distance travel, KPIs, distance travel, time spent, and fuel consumption. In the first phase, this phase, so also in Valencia for Valencia and Alba Iulia, the data means the data before applying the pilot, before experiencing the pilot. In the second phase, we collect the data with an eco-driving alarm application, plus the optimized route that we explained before. Without the sensors. This is without the sensors. Okay. So, and in the last third phase, we see we collect the data, installing the file level sensors that through the route of the app will guide the driver. So we can see obviously the continuous improvement without not having the pilot, having the pilot but without the sensors, and having the pilot with the sensors. So we can see a reduction for Valencia and Alba Iulia for both in the three main indicators of the project, in distance travel by 34% and 21%, time travel 28, 12, and fuel consumption 18 and 12. So it was a good pilot. So that's it. As a conclusion, we can observe obviously a percentage reduction in the indicators that represent the improvement of the transport part of the PlastiCircle project. So thank you everybody for listening to me.
Thank you so much, Ricardo. There were quite a few results to go through, and the results have certainly been impressive on SAF's part. So congratulations on your role in the eco-driving and route optimization innovations. And now if we could switch to the sorting innovations, and we have the Managing Director of Big Visa, Luis, the floor is yours. We can't hear you, Luis. There you go.
Can you hear me?
We can indeed. The floor is yours. Thank you.
Okay, thank you. So thank you everybody for attending. Can you confirm, Matthew, that the screen is being shared?
I can confirm, yes. Thank you so much. And I'm afraid you've drawn the short straw, Luis. I'm afraid you'll have to be very brief, if that's okay. But okay. Thank you so much.
Okay, I'll try.
Thank you so much.
So we are in charge, Big Visa is in charge of the sorting work package of the project. So we had as objectives focusing on the main plastic fractions available in the market, let's say. So most of them were mainly PET, polyethylene and polypropylene, both in the rigid fraction and also the films. We aimed to reduce the material loss and improve the precision in sorting. A special focus of the project was for the film fraction, which also was due of the study for the stabilizing the film, which we'll go through. And then we also wanted to reduce the percentage of valuable material in the reject fractions. So our task was divided into 5 different tasks, going through software improvements. We also placed the technological study for the state of the art of the technology. We carried out a prototype for the stabilizing the film on the conveyors. We also had a study of the air turbulence for these fractions to improve the sorting separation. And we carried out pilot studies testing from 3 cities around Europe: Valencia, Utrecht, and Alba Iulia. So regarding the software, a special focus was made on the PET in order to separate accordingly monolayer bottles, monolayer trays, and multi-layer trays. Regarding the film fractions, main focus on the multi-layer materials and separating polypropylene from polyethylene. As you can see on the table on the right, most of the combinations of materials were achieved. Still some struggling with the technology for separating multi-layer materials between polyethylene and polypropylene. Rest of it was achieved. So good conclusion on that in that sense. Regarding the technological study, we had a study put in place in order to determine if whisk broom spectrometers or push broom spectrometers, which is the best option for industrial solutions. At the end, we concluded that push broom technology, which is the one we used in our equipment, is the best technical and economical solution in the market, because whisk broom spectrometers do not have industrial solutions put in place. So we carried out also a prototype for the film stabilizing in the conveyors of the optical equipment, which is known in the market that film, since these conveyors are run at a very fast speed and the film has very light weight, does not convey accordingly in the conveyor, so it makes it hard afterwards for the separation process. So the new prototype was placing another conveyor with pikes, which creates an air funnel on top of the conveyor, and then helps pushing down the film on top of the conveyor. And so after the detection, the separation is made with a more precise result. We carried out an air turbulence in order to convey these light fractions, which once they are blown, they do not blow. They do tend to blow randomly. So we created modifications on our flying box in order to convey these materials accordingly. As you can see on the right, materials where after the modifications, the film fraction is conveys much better than before. At the end, the results on the testing were concluded that the faster the speed goes on the conveyor with the prototype, the better the results are, which is very good in terms of production in an industrial basis. Regarding the pilots, the results of the pilots, we had aims to go with purities and above 95% overall, and reducing the reject fractions. So the results on the Valencia city pilot were that we achieved for the PET and for the polyethylene the results. We went over the results of the project, so that was a good result. For regarding the film, we are still struggling. We are 2% below the objective of the initial objective of the project, but we're struggling. And in the next 2 city pilots, we will be able to achieve the results that were aimed at the beginning of the project. So overall, the work package has a successful results, and so we're happy on that. And yeah, that's it. Made it fast enough, Matthew.
Thank you so much. Thank you so much, Luis. That's fantastic. Very succinct and very clear presentation as well, with very clear results. Peak Visa has been instrumental to the success of the project, so warm congratulations. Now I've just received some word from our co-moderator, Miguel, who has been receiving some of your questions in the chat. And if I could just read perhaps one of them aloud. I think we had one curious member of the audience who wanted to know if the system during transport defines the optimal route, or is it just collecting the routes done by the trucks? Well, actually, the system, to answer your question, defines the optimal route. It minimizes distance and time, and it also avoids certain containers which are not full enough, if possible, so that these can be collected on future routes. So indeed, there are all manner of innovations in the collection phase. And of course, we received another question from a curious member of the audience. 50% filling level for the smart containers is a starting point reference. It's maybe good to integrate artificial intelligence to understand the rotation per container and redefine the reference percentage to trigger a collection event. It's a very technical point, technical question, but very interesting nonetheless. We've actually, according to ITENE, we've actually worked on this so that the parameter is flexible and adaptable, and as much information is gathered during the smart container process so that this factor can be optimized. There's a great deal of work which has been done by the ITENE, SAV, and Big Visa teams in that regard, but the work, of course, continues beyond the PlastiCircle project. So with that, it is now 10:16. And it is time for a coffee break. So please, if you could all feel free to just enjoy a coffee and a quick break from the screen, and we'll reconvene a couple of minutes before 10:30 when we'll hear from Alicia Martin of Plastics Europe. Okay, thank you.
In the European Union today, people and institutions are mobilizing, moving away from the economic model of the past to a more sustainable way of life. For too long, our linear model, where we take, make and dispose, has stunted growth and harmed the environment. Now we are working towards the circular economy of the future, where products and materials stay in the value chain for longer and are recovered at the end of their lifetimes to be used again. This includes plastic. In the EU, more than 25 million tonnes of plastic waste are produced each year. Not even a third of this total is recycled, which means economic losses of over 10 billion euros. What's more, 63% of the waste produced is packaging waste. Often, we don't recover much of it. It's low quality, and we have low value applications from what we do reuse. Not to mention big environmental impacts, such as plastic marine litter and CO2 emissions of some 24 million tonnes a year. In other words, there is work to be done. The PlastiCircle project, funded by the EU's Horizon 2020 Research and Innovation Programme, is one of a clutch of strategic European initiatives that aims to rethink the way we treat plastics. For PlastiCircle, plastic packaging is too valuable to waste, so we want to close the loop and transform it into valuable recycled products. For PlastiCircle, 20 organisations from around Europe joined forces to launch innovations in 3 pilot cities: Valencia in Spain, Utrecht in the Netherlands, and Alba Iulia in Romania. We are rolling out innovations across the plastics value chain, in waste collection, transport, sorting, and recycling. We have designed smart containers to increase collection rates of plastic packaging waste. We are introducing a more cost-effective waste transport system connected to an Internet of Things cloud platform. We are developing innovative optical technologies to improve sorting, and PlastiCircle is developing new, added-value recycled plastic products. Products such as automotive parts, foam boards, garbage bags, roofing felts and membranes, and urban furniture, all for market, all from post-consumer packaging waste. But the PlastiCircle approach can also stimulate new businesses in waste management, reduce the landfilling of plastic waste, save CO2 emissions, compensate citizens for eco-friendly behaviour, and the approach can also generate employment in European economies. Citizens, towns and businesses can all get involved. You can keep track of our innovations and see our results for yourselves. Follow us on Twitter, subscribe to our newsletter for updates, or visit our website for the latest news, views and project information. Follow PlastiCircle today, for plastics in a circular economy, for a more sustainable world.
Good morning again to all of you. Thank you very much for coming back to us after a quick coffee break. And now very swiftly, I would like to move on to our next presenter, who of course is the Iberian Regional General Manager for Plastics Europe, and that is Alicia Martin. And Alicia will be joining us before a couple of other presentations later on, during which we'll actually hear from the 3 pilot cities, Valencia, Utrecht, and Alba Iulia, and then of course on the innovations that have been undertaken by the PlastiCircle project, and we'll be hearing about them from Keen BVN. But first of all, Alicia, if I could turn the floor over to you, and please, if you could begin your presentation. Are you connected properly? Yeah. Okay, the floor is yours, Alicia. Thank you. You're going to have to unmute yourself if that's okay, Alicia. Right. So I'm afraid we can't hear you at this time. And if you could just bear with us while we try and resolve this sound situation. There we go. We have live. Fantastic.
I think that So can you
Excellent,
confirm
Alicia.
that you can see my presentation?
We can hear you well, see you well, and we can see your presentation. You're all set. Please, the floor is yours.
Okay, so thank you very much for the introduction, Matthew. And first of all, thank you very much for the invitation to this panel. I'm very pleased to share with all of you our work in progress towards circularity and some of our challenges. Of all the things I expected to experience in my life, hugging my parents virtually from over 1 year now was never part of the plan. So one of the things that we learned from this pandemic is that change is the only constant and we can only embrace it. In fact, many businesses throughout Europe have some great stories of resilience, and they have reinvented themselves to answer to these challenges and to turn these challenges into opportunities. So I really think that this is the lens through which we need to see the world. So make the best of this difficult time and unlock the unseen opportunities. So with this lens, I invite you all to a quick travel through our new circular economy. I believe that circular economy is the only way we can tackle our present and future challenges. Circular economy also enables new solutions and new products to benefit society as a whole. Of course, we are all changing, and we need to work with all the players to be successful and also to truly deliver one circular economy vision. So what is this circular economy vision? Please imagine the impact of all of us coming together to find solutions to some of the most pressing needs. For example, building cities for people, or driving green mobility, or making people's lives longer and healthier. This is the great story enabled by a circular economy, in which each of us is a protagonist, and we all have a key role to play. So I must say that we are all level players in the circular economy. Of course, for us in Plastics Europe, we think that circular economy goes beyond just recycling and plastics packaging. Circular economy is a lot more than that. I must say that our industry is proud of the versatility of the plastics materials, but we are also aware that plastics waste and plastics littering is one of our main challenges. The plastics industry, as change makers and enablers, we must play our strength and pursue innovative solutions. We recognize we are part in creating the issue, and we are also working in finding solutions, and we remain committed to deliver societal benefits without having a negative impact on the environment and also on health. It's only through a systemic shift towards a plastic circular economy that we can deliver on this shared vision. So, how does the long-term vision for the industry look like, you might ask me? Let's go and see on the next slide. We talked to the key stakeholders from all the walks of life, including also our critics. We did a listening exercise, and of course we had some positive feedbacks, but also we had lots of things that were uncomfortable to hear. But what we found out in this exercise is helping us to shape this long-term vision for the plastics industry. I might say that our overarching vision for the industry is the same as the vision for the policymakers. And what is this long-term vision for us? It's an industry that helps to deliver climate neutrality and the creation of a competitive circular economy. So I am excited about the progress being made and our direction to travel. We are working together and towards long-term sustainable changes. All of this based on science and innovation, because science and innovation is the aim for our plastics industry. This working in progress requires solutions. And of course, those solutions require innovative technologies. For example, innovative technologies in the area of recycling, also innovative technologies in the diversification of feedstocks. We need also infrastructure projects. We need new business models. We need new materials, new designs. We, as polymer suppliers, we are invested millions of euros in capacity for chemical recycling to complement mechanical recycling to help us to achieve the recycling targets. We are also focused on sustainable consumption and production. And this focus makes us to rethink everything from the product design to the way we deliver a product to consumers. Those are promising challenges, but I think that are also opportunities where plastics can play a vital role. Of course, we echo the DG Environment views. We need to shift from plastic seen as a cheap material and also to increase the understanding of the value as resources. For that, we are working with policymakers, we are working with our supply chain partners, and we are working with other stakeholders to solve our pressing issues via partnerships, via alliances, and also open dialogues. Success, we think that success relies on the commitment of the whole value chain, also of the commitment of the policy and local communities. And of course, PlastiCircle is a clear example of what we can achieve all together and all we can achieve sharing a common circular economy vision. In Plastics Europe, we believe in the power of partnerships. We think that alliances make the world go round. This is a snapshot of our collaborations and partnerships at European and also a global level. And I will give you some examples of these collaborations. For example, at European level, we play a leading role in the Circular Plastics Alliance together with 270 members. And in this Circular Plastics Alliance, we are developing a roadmap to deliver 10 million tons of recycled content by 2025. Of course, PlastiCircle project with a consortium of 20 partners working together during 4 years is another example of good collaboration. But we have also partnerships at European level, at global level, sorry. And why we have those partnerships at global level? Because we believe that Europe and also the plastics industry are and should be at the forefront of the global response of plastics waste. I think you can agree with me that plastics waste is a clear global issue, and collaboration at global level is just as important as collaboration in Europe. Europe is leading the way in addressing plastics waste as a global level, and we are creating some collaborations and the best possible policy framework with the United Nations and others. And we are also very active and collaborated at global level through different examples. And I will give you some of these examples. For example, Plastics Europe is the European coordination of the global initiative Operation Clean Sweep. And we have over 1,200 signatories. And this is a program to zero pellet loss. And we are also member of global initiatives like, for example, the World Plastic Council and also the Global Plastics Alliance. This focus on how to reduce marine litters. But I think that you can agree with me that we cannot speak about circular economy without speaking about decarbonization. Both concepts are the two sides of the same coin. So, the European Green Deal is the North Star for our member companies in Plastics Europe and for their investment strategies. Our industry is crucial in delivering on the European Green Deal's ambitions, and we support the European ambition to become a climate neutral continent by 2050. For that, our industry is taking many actions, and I will give you some examples. We are increasing the circularity of the plastics value chain, as I explained before during the presentation. But we are also accelerating the use of renewable resources. We are also increasing the use of renewable energy and electricity, and we are developing carbon capture and use technologies. So it will be important to link up these benefits with our circularity work to ensure net environmental improvements. But to make the European Green Deal a success, our commitment and also the investments of the plastics industry need to be supported by the European Commission and also by the legislators. Ensuring an harmonized policy and also a regulatory framework is key to support industry through all this transition. We need a consistent and uniform framework. We believe that the European single market is the best driver of a circular economy, and we need to really protect this European single market. All of the main areas where plastics make a contribution are now considered also key product value chains by the Commission, but also the plastics waste need to be recognized as a valuable resource. And I think that here the claim of the PlastiCircle project is very good for that. Plastics waste is too valuable to waste. So I would like to close this presentation with 3 key messages. I believe that the opportunities that circular economy gives us are limitless. It's what will make the impossible possible. The circular economy will inspire us to be more creative, to be more innovative, to be more ambitious. and it will take us anywhere. Is the lens through which we see the world. Is the blueprint to creating new solutions, new products to benefit society as a whole. And of course, we can be successful only by working together towards a one circular economy vision. So thank you very much for your attention, and congratulations to all the partners which made PlastiCircle a reality and also a successful project. Thank you very much.
And thank you, Alicia, for a very comprehensive overview, the industry perspective, but not just the industry perspective. Of course, you also mentioned a common theme running through today's proceedings, which is, of course, the Green Deal, the North Star for circular economy and decarbonisation investment strategies. And I think we'll probably move on to that later on and cover more of that. So please, I hope you or your colleagues will be available for questions as well. Thank you so much, Alicia. Thank you.
Thank you, Matthew.
Now, if we could move on to a particularly interesting part of today's proceedings, and that, of course, is to hear from the cities. Now, of course, PlastiCircle innovations were rolled out in these three cities, in Valencia, in Utrecht, and in Alba Iulia. And today we're going to have a particular perspective on what happened in these cities, not just from the perspective of new technologies, but also in terms of public engagement, in terms of how people got involved in PlastiCircle, because of course this is partly the crux of the matter. So if we could start with, I believe, Julian Torralba from Las Naves, which is Valencia's Innovation Centre. Julian, are you available, and can you join us on screen? Fantastic. I'm afraid you're going to have to unmute yourself, if that's okay,
yes,
Julian.
That's it. I think now it's okay.
Perfect. It's good to see you again, Julian. And if I could ask you to take the floor before Frank from Utrecht and Valentin from Alba Iulia. So the floor is yours, Julian. Take it away.
Okay, I assume you are watching my screen, my presentation. So
perfect.
Let's go. So yes, we are going to present the Valencia pilot, which was the first pilot to be launched. So all the new technologies were tested for the first time and check and improve for the rest of the pilots. So I would talk about a little bit about how was organized the pilot, how was the development of the pilot, and the results and the impact of the city. So it is important to start saying that the pilot of Valencia was related to 2 out of the 4 stages of the cycle of the circular economy cycle or PlastiCircle, which were transport, sorting, and transport. So we tested the innovations related to these stages. Just to start with, we tested this is Valencia. For those of you that don't know, we are in Mediterranean city in Spain, and we tested the pilot area was district in the south part of the city and the outskirts of the city called San Marcelino, and which we knew some statistical data, which, for instance, the population density was very high, higher than the average of the city. But other than that, we realized that we didn't know nothing more about the district. So we had to know more knowledge about the people living there, what they think, how they manage, how they struggle with the sorting of the waste. Packaging waste. So we designed this pilot in 3 phases. Which were the pre-pilot, and the pilot implementation, and then the end of the research, and to use the technical development that started since the beginning of the project. Of course, once the pilot started, the technical development were ready, but of course they had to be, let's say, adapted to this live environment of the pilot. So let's go to the first part of the pilot, the pre-pilot, which it was the main objective was to know the area, to meet the neighbors. It was very important to know from the first hand, face to face, what they thought about it, where which were the main concerns about the sorting process and management in the district. So we ran several workshops with an open to all the neighborhoods and other interviews with the specific key stakeholders of the district, like neighborhood associations, sports associations, and cultural associations of the district. We also ran interviews in the street for the, directly to meet the neighbors, and we draft it, and we got some valuable conclusions that would help us to tailor the communication campaign and the engagement campaign so that the pilot could be successful in the city. So some of the main findings that we in this phase that we just could know that is, for instance, that related to the population was the elder population was higher than the average of the city. So that if we wanted to run a communication campaign based on the internet, in the social media, but we realized that that wouldn't have been very successful because of this profile of the population. So we have to, of course, we couldn't avoid the social media, but we put more weight on being present in the district. So we design more specific actions in the streets of the district. Also, it was about the messages. Of course, the message PlastiCircle is about sorting and recycling, but this is most of all is about circular economy. And we realized that the circular economy concept was not very, let's say, very well known by the population. So they were very aware about how important is recycling and sorting, although they didn't know how to do it, but they knew it was important. But we realized that they didn't have this bigger scope or bigger picture about the circular economy. So we had also to stress the messages about it is important to sort at home, to do it correctly, but why? Because it has an impact in the whole waste management. And that could doing it well, you can improve the rest of the stages. So this is also very important, and this helps us to tailor also the messages of the communication campaign. So once the pilot started, so we were ready, of course, thanks to this pre-pilot phase to launch the communication campaign. As I said, it was very present in the streets, but we also use this social media in terms of gamification, as my colleagues have explained in previous presentations. There was a points scheme, so that was fit basically by participating in the project. Let's put in the waste in the bin, but also you could also have more points by participating in other campaigns. So our idea was to involve the citizens in a lot of complementary actions involving the circular economy concept and the benefits of the concept. For instance, we launched an exhibition, a photograph exhibition in the district, where they could about the negative impact of bad waste management in the environment. So they could see which is the impact in the global warming and in the climate change. And also, for instance, we just reinforced the idea of new products made out of plastic, made out of waste. We also use this bench made out of plastic waste that we install in the district, and they had to find it and then to share the location. So the idea was, as I said, to get them involved in several activities, not only in the basic activity of the pilot, but also in a lot of more activities, so that during these months of the pilot, let's say, they got the idea, the complete idea of the circular economy, and not only about sorting. Of course, the the basic actions of the project was the engagement of the citizens. So we run a specific a campaign with a specific image, a tailored image to be more attractive to the district. Super Marcelina was core, and a lot of activities and workshops focus on specific target populations. So in schools, in sports centers, in neighborhoods, in housewives, so that they could, in the first, of course, to register to participate in the project, but also even if you don't register, to get that information about and to solve doubts about how to sort it properly, how to sort properly at home the different kind of waste, because there were a lot of doubts about aluminium or about packaging and cans and plastic objects. So, a lot of doubts and a lot of misunderstandings about how to do it properly. Also about the technical, we tested, of course, the devices. We were aware that we had to do some adjustments. Pictures shows the main, let's say, problem that we had about the malfunctioning because of vandalism of the stickers dispenser, but that had to be fixed, has to be reinforced with a new design to assure the proper delivery of these stickers that were crucial to identify the users. Also, in terms of the signals of the filling sensors and the location sensor of the containers, during this pilot, several improvement had to be done to achieve the full coverage of all containers. That in the end, after several tryouts, we just achieved to have the full coverage of our containers by installing and changes the position of some LoRa antennas or receivers. Also about the route optimizations, it was an ongoing work during the pilot implementation. As you can be in the beginning, the thicker blue lines, the thicker the lines are, the more fuel consumption and more emissions. So you can see that in the second phase that the improvement are evident. And as final results about participations, we met the goal. And we are happy because of that, but it is also true that the main participation and registration was in the first weeks, and it was less intense in the middle and the end of the pilot. Because it was in the middle of the summer season, which was not very positive to get more the people involved, but still it was very successful in terms of participation of the number of participants. About the technical results, the pilot in Valencia and the improvements in the technical part, but improve, let's say, the technologies used, and it was very important because it had to be a technology transfer to the pilot of Alba Iulia. So we improve of course, the label dispensers, I say, but also we improve the LoRa devices and also some structural and hardware parts like the rain infiltrations or the car's malfunctions were also fixed, so that Alba Iulia could not have to deal with that problems. And about more specific results, I would like to highlight that in terms of characterization, for the pilot users, you can see in the first table that the unwanted percentage of waste is much lower than for the non-pilot users, which is a clear advantage of the pilot, let's say, good result. And in terms of in weight, also we can see that in percentage, it is much lower in the case of the users. In the case of the people participating actively in the project, are much better than for those that didn't do it. So people participating in the project got the knowledge of how to do it properly, how to sort the right waste in the right bin, which is crucial to start in the right foot the next steps of the chain of value. In terms of transport, we can also see that it meant an improvement of the emissions, of less emissions, of course, and of course because the system of keeping containers that were not completely full, so the system allowed to redesign the route of the trucks to, let's say, to avoid these containers that were not completely full, so that would mean to the save of time and save of fuel consumption eventually. And also, of course, the biggest, let's say, results of the projects for us, from our point of view, it was the user satisfaction. These are pictures taken from the last event. It was the release of the awards. You can see below on the left picture of one of the winners receiving the scooter, which was the best prize. So in the end, the people was so happy to have him, for having participated, for having contributed to these results, to this improvement of environmental improvements, CO2 emissions, and in the efficiency of the system. So this is a very satisfactory for us to see how their involvement, they were also aware of how they contributed to these results. So, and this is also our best, let's say, our most important message for them, no? That you not only have participated, but you have contributed to the improvements. And what happened in Valencia beyond, how PlastiCircle has contributed to the policy of Valencia city in this area. So, in first place, Valencia participated in this project because of course, the improvement of the sorting and collection of the waste is one of the priorities in terms of environmental policy. We can say that PlastiCircle has fed the other initiatives that are currently being carried out in the city council, or that will be done very, very soon. I would like to highlight these three campaigns and these three also pilot experiences in the city, because so that you can see that how PlastiCircle has impacted in the Valencia City Council. So the Valencia City Council is still very, very, very interested in the compensation system, in rewarding the people for doing properly, and we have also started a new system related to more focus now in bottles and cans, so that people can get points as well, very similar to the points of PlastiCircle, but another kind of point that they can redeem by other awards and discounts in social services. Related, also very important for us, how it is linked to the smart city strategy, how all these data is also takes part of the big data of the city that can be used by any other developer. So this is similar to PlastiCircle, and based on the experience of PlastiCircle, we have now running a pilot of almost three filling sensors in other parts of the city, that we also improve the transport operations, the waste transport, so that's aiming at reducing the CO2 emissions. Also very, very important, we have proof that how important is very focused, specific, very well tailored and designed communication campaigns to get best results of the people. So City Council has taken note. We are launching, City Council is launching, for instance, this is one of, I think it was launched 3 months ago. It's focused on these specific ways that also has arise a lot of doubts about the people, and that have been identified thanks to PlastiCircle, or PlastiCircle has helped to identify the main, let's say, barriers and the main problematic ways. In this case, it is a campaign focused on the coffee capsules that now in Valencia they can be they can be put in the also in the yellow bin. So we can say, we are happy to say that PlastiCircle has contributed to the policy, to the waste policy of the City Council, and that here has to be and that is going on in the spirit of PlastiCircle is going to be kept at mid-term and at long term in the City Council. Well, this is all from my side. I will remain at your disposal if you have any specific questions about the project.
Thank you so much, Julian. That was a very comprehensive overview, and really reflects the extensive work that was done by Las Naves in Valencia, especially a masterclass in public communications and public awareness raising. And of course, we move on to another context, which is of course the city of Utrecht. Frank Donkers is with us. Please, Frank, could you move on and tell us what happened in Utrecht? How did the PlastiCircle project go, and what successes and challenges did you have? Thank you.
Thank you, Mathieu, and good morning, everybody. And I will try to enlighten you more about the case in Utrecht. Can you all see my screen at this moment? I think so. Yes.
Perfect, Frank. Yep, we see you and we see your presentation.
Good. Well, our pilot, just like in Valencia, consists of multiple stages. First, I would like to take you through the pilot with our participants. We selected 2 areas in the city of Utrecht, in the west of Utrecht, both with a number of households and with a specific collection method of mini containers. Each household has its own mini container in this area, which were collected once every 3 weeks. Just like, and on the picture also see the platform which we use to engage our participants for this pilot. First, we talked about the communications. We did some recruiting in the area. We did some recruiting online, offline. Then we held a kickoff workshop with all the participants, which was really fun to do. Which also handed out some goodie bag with some useful information, how to get the plastics, how to dispose of the plastics, where to bring it, which characterizations the plastics have. To keep them engaged, we had weekly assignments, we send out newsletters, and we made some videos. On your picture, you also see our Madame Plastique. Within the participants, this became like a local hero for them. There were old movies about her who actually took up the phone asking weird questions about plastic to the contestants. We had a technical visit from the partners from the PlastiCircle project, and at the end we distributed a glossy magazine to the participants, which summarized all the results. And the pilot assignments, we had some, this was the platform. We had some weekly assignments on them to keep the participants engaged. Most of them were quite easy for them, like how many plastic packages do you open every day, or how do you separate your plastics at home. The results are actually quite interesting already. We found out that our participants open 20 packaging every week. And with our other projects we've held, this is actually quite low. Average household in our city does this ×3 a week at least, I think. But also we asked about how do you do it outside when you're not at home, when you're on a holiday, how do you look at plastic separation there when you're abroad? And because we had the Christmas holiday during our pilot, it was also interesting to see, does your separation change when it's a holiday and you're busy at home, or when you have more free time? What kind of effect does that have on your plastic separation? At the end of the participants, we held a panel discussion. This was when we covered some theses. We presented them with some theses about plastic legislation, about plastic production, about plastic collection, like our own efforts as a city, and about the plastic recycling. As summarization about this is people don't think plastic should be prohibited or anything like that, but they do think the plastic should be made more for recycling. And even government investments should be necessary to help that. And the most thing they kind of hated about the plastic packaging was there was no information on the package itself on what to do with it after you're done with it, disposing it. So they had not a clue how to recycle it. The weights characterizations, to measure this, we had held some sorting analysis over the collected plastic waste in the pilot area. We see the pre-pilot, the plastic was 51%, and at the end of the pilot, 54%. We see a small increase in the number of percentages of plastic packaging in the waste. In the middle of the pilot, you actually see some more increases of 75%. This could also be explained because that was the Christmas time, and like they said on the first question, they open a lot more packaging when it's Christmas. So there's more packaging, I think, than other waste at that moment. The next part of the pilot was truck traceability and driver guidance. We have installed, I think the Las Navas presentation already covered a lot of this. We installed 3 canvas readers on 3 different trucks, 2 top loaders for our underground bins and 1 rear loader for our mini containers, and which we tracked the amount of RPMs, the tracked the fuel amount, the kilometers, the time driven. And that's a moment where we could be intervening. That's when COVID kind of hit. And I was not able to give a presentation to our drivers about how to use the app, how to install the app, how to go on about this in the pilot area. So we did not finish this yet, but the last part of the intervention is taking place now. The app is installed and some last issues are being dealt with at this moment, and then we'll start this and finish it before the end of the project. The last part of the pilot was the plastic optimization process. This was a bit different for our city because at the start of the pilot, we already had 3,500 sensors installed in our underground bins, and we already had our route optimization system in place. But this gives us, of course, an opportunity to compare the both projects to each other. So what we did was we took 10 routes which had been executed in September of 2019. We brought that back to theoretical routes because that's that way you can have it more compared. And we compared that to the Iot platform which was developed for the PlastiCircle project. At that we calculated the total time, the operating time, the route time, and the pause time to be able to optimize the routes. In the comparison, you'll see that the plastic circles can go up to 6 trucks, and it works in bigger scales with several trucks, just not like in a whole city environment. Theoretical, the PlastiCircle Iot platform would work, and it would actually do a bit better than our own platform at that point, which will be because it will be able to reduce as well in time as in distance for the routes. I think that's a very short overview about the pilot which has been dealt in Utrecht. I'd like to thank you all for listening, and if you have any questions, I'll be happy to answer them for you.
Thank you so much, Frank. Really appreciate your overview of some of the particularities of Utrecht. All three cities were very different, and in that regard, we'll also hear from Alba Iulia just now, and with Valentin Voinica, who's going to go over some of the challenges that you had in the Romanian citadel city. Please, Valentin, the floor is yours, and of course, just to the audience, if you have any questions, please don't hesitate to let us know in the chat, and we'll put them to the speakers as soon as possible. Valentin, over to you.
Hello, thank you, Matthew. Do you see my screen?
I do indeed, ready to go.
Thank you. So we'll present something about the implementation of PlastiCircle in Alba Iulia in a different context. So I think it's important for the replicability of our project. We will discuss about the pilot area and the implementation specifically to Alba Iulia, technical implementation, communication, and results. First of all, Romania is in a different context. We have a certain delay in implementation of circular economy procedures, but good news is that new legislation is implemented day by day in several cities. In this moment, we are focusing on shaping social norm and improve citizen behavior. That's why we are focusing on collection and transport, like all other pilots, and we will have some specific objectives. It is a moment to say that it was a collective effort, and we would like to thank to our local partner, which is Polaris, the waste management company, but also to partners like ICLEI, SAF, Sintef, and Plastic Europe, and so on. Practically, the pilot in Alba Iulia was a team effort, and that was very nice from our project. On local objectives, we have the same, improving the circular economy of plastics, but we put a lot of effort in informing and involving citizens, in testing innovative solutions like smart container and traffic route optimization, and also to receive feedback from citizens and all local stakeholders. About Alba Iulia, we are a smaller city, about 74,000 inhabitants. Our containers are much smaller. We are using in this moment Euro containers, 1.1 cubic meters. We used dedicated container for PlastiCircle fraction. We have a local project to improve to 4 different recycling fractions, and the truck has rear loading instead of lateral loading in Valencia or using a crane in Utrecht. So about the corona effect, we are the only pilot that was implemented during the restrictions caused by corona pandemic, and that's affected a lot our plan. We have to delay about 3 months our pilot, and we have to do a lot of activities online instead of offline. So this was a problem in interaction with our citizens, and we have to change our strategy. It was also a problem in getting local support from our partners, but they were very helpful online, and we managed to implement all the solutions. About the district area, it's a very well populated area, over 4,000 families living in this area. You see on a picture with yellow existing local containers locations, and with blue new containers during the PlastiCircle project. And with red balloons, you see the transmitters used to take signal from the containers and take it to the Iot platform in Valencia. Our pilot is very close to the implementation made in Valencia, but a lot of adaptations were made to local conditions. For example, first of all, we had to adapt the filling sensor to our container and also change the reading frequency, because Our containers are small and the containers are filling very fast. We successfully adapted the identification module, which is using the RFID card of the citizen and is generating a label for the principle of pay as you throw and also for individual characterization. About transceivers, as in Valencia, we use local transceivers taking signal from container and sending the signal and data back to Valencia. The area was very narrow and we used all the 11 transceivers we had for a good coverage. We also used just one but dedicated truck we used just for the PlastiCircle fraction. And you see the map implemented with the help of our colleagues. And, in communication, we have a local logo as a combination with the project logo. And we were forced to develop a lot of online and offline materials because we missed some local events due to restrictions. And we also have a good video presentation for explaining how to participate in the project. About results, you see that in this graph, in the second part of the pilot, we have a spike was generated by the info kiosk with directly engaged citizen. It's a good value considering the restrictions, about 476 citizens involved, 13,000 in social media, and we used a lot of offline materials, leaflets, brochures, and so on, in order to achieve these numbers. You see the characterization results, and this clearly defines a good result obtained by the participants of the pilot, a very good number for compacted and content of plastic instead of unwanted. In general characterization also, we saw an improvement of plastic quantities in PlastiCircle containers. So these are quite good results, but a lot to do also on sorting locally. About the composition, PicVisa is going to replicate the composition from Alba Iulia because we weren't able to send some samples directly from Alba Iulia to Valencia and to Barcelona. What is different is that we have a small component of PVC, which I think it can be sorted by our partner PicVisa. About route optimization, the pilot route is only 50% compared with those in Valencia, but we obtained some good results in terms of optimization and skipping 2-3 containers with lower frequency. So we are considering over 11% in terms of consumption and also in distances. In eco driving, because the speed inside the pilot area is just 7 kilometers per hour, we have a small result compared with Valencia, which obtained 11%. But this situation will change dramatically at the city scale. About participant feedback, just a few data. Majority of participants want an improvement of the local system. They want to pay as you throw and according to correct recycling, or exchange some eco points like we proposed. And general feedback was very good for our consistent interaction with citizens, over 75 having a very positive reaction, good project, and want to implement the project at the city scale. I think that you have some details about the local implementation, and thank you.
Thank you so much, Valentin. Excellent summary, and really encouraging to hear that, of course, the citizens of Alba Iulia really want to scale this up and take this local pilot project onto a much broader city scale. So very, very encouraging indeed. Thank you. Yes, before we move on to the final presentation of the morning by ITENE and ITENE, you've been sending in your questions thick and fast, and a number of our experts, especially Miguel Angel, our co-moderator, has been dealing with these in the chat. So please, even if they're not addressed by myself or live and direct, they're being addressed behind the scenes. Please don't hesitate to send your questions through. We had one on chemical recycling. Could it be possible for more details about chemical recycling? Well, as you know, PlastiCircle is mainly focused on mechanical recycling. However, a number of the partners have a huge amount of expertise in that field, and so can answer any detailed questions. Right, listen, before we break for lunch in 34 minutes, if I could direct your attention to two speakers who will be dealing with the PlastiCircle business model, which has pricked the interests of quite a few people in the chat as well. And if we could pass you over to Ariadna Balada of ITENE and Miguel Angel from ITENE. Please, Ariadna, the floor is yours. Please kick us off with PlastiCircle's sustainable business model. And if you could unmute yourself, that would be great. We cannot hear you. Just bear with us 2 seconds while we address this. Miguel Angel, I believe we can hear you. Is that correct?
Yeah, can you hear me properly?
Absolutely, yeah. We can. Yes, you're on after yes. Ariadna.
Sorry, I was trying to share the presentation.
No problem at all, Ariadna. Yes, so the floor is yours. Please proceed with your presentation. Thank you so much.
So sorry. Can you see my presentation?
We can indeed. That's perfect.
Okay, perfect. So sorry, I have technical problems. My name is Ariadna Balada. I'm from Barcelona, and joining with Miguel Angel from ITENE, we are going to present PlastiCircle. Sorry, you are. I think I'm not sharing properly the presentation. Okay. Now?
That's perfect. Now you're ready to go, Ariadna. Go for it.
Okay. We are going to present PlastiCircle sustainable business model to foster circularity. We will present you the innovative, sustainable, and cost-effective advantage of the results developed in the project and the contribution that PlastiCircle solutions may represent in the sector. Sorry. So, which is the starting point? In 2019, almost 58 million tons of plastics were produced in Europe, which represents the 16% of world's plastic. The 50% of the total plastics produced, 29 million tons of post-consumer plastic waste, were collected in Europe in 2018, but the 25% of this was still sent to landfill. If we focus on plastic packaging, almost 18 million tons of these products were generated in 2018, which represents 61% of total plastic waste, being recycled the 39.5%. Low recycling rates of plastics are due to different factors, from citizens' behavior and environmental awareness to technical difficulties in sorting certain types of plastics and their quality for being reused. So what is the solution proposed by PlastiCircle? PlastiCircle presents an integral system of smart waste management with 3 areas of action: collection, which aims to increase the amount of plastic waste collected; transport, desiring to reduce the economic and environmental cost of recovered plastic; and sorting, with the objective to increase the quality and quantity of recovered plastic. And what is the difference between other systems? PlastiCircle is modular, economic, and easy to install. It's modular because we have different technologies that can work together or alone. Economic because you can use the containers, trucks, and sorting installations you already have, and easy to install as it has been proved in the 3 city pilots. Before going into detail, I just want to do a quick view in PlastiCircle technologies as they have been explained before. PlastiCircle solution integrates an identification module for a smart container a route optimization tool, and eco-driving guidelines. All data received from these are integrated in an IoT platform, which allows to implement a pay-as-you-throw system. In addition, it has been improved the optical sensor and developed a film stabilizing conveyor to improve sorting. Just some points about these technologies. The identification model for a smart container can fit to any existing container, reducing the cost of turning your waste management to smart. The route optimization and eco-driving can be adapted to your waste management fleet. All the technologies are compatible with any commercial filling sensor, and it can be all integrated in the IoT platform developed. The plastic sorter with the conveyor film stabilizer can be added to your actual sorting facilities, increasing the capacity of turning your installations in classifying difficult to recyclate plastics. And which are the benefits of PlastiCircle solution? The pay-as-you-throw system increases awareness of citizens about recycling and its impact on society. Route optimization and eco-driving can reduce CO2 emissions in municipalities. And the improvement in sorting allows to recover plastics that was discarded to landfill before. And why now? We need to reduce greenhouse gas emissions to fight against climate change. And Europe has the objective to be climate neutral by 2050. PlastiCircle modular system can contribute to any European city to adopt an easy and economic smart waste management, with a direct impact on the reduction of CO2 emissions. In the following slides, Miguel Ángel Gorrit will explain the impacts of PlastiCircle with the life cycle assessment realized. Miguel Ángel? Miguel Ángel, I can hear you.
Now, can you hear me?
We can hear you. Okay. We can hear you now, Miguel Ángel. The floor is yours.
So, yeah, as Ariadna was just introducing, well, in every business we also have different aspects to consider, and here you can see a bit conceptual map on the work we did to evaluate different impacts, considering collection, transport, different sorting schemes, all the washing and pretreatment that plastic needs in order to be converted into pellets or flakes, and the different applications that were developed in the project as end products. So if you can pass the slide, Ariadna. Yeah. Mainly in the project, we worked on environmental, cost structure, and social impacts from the project based on LCA, LCC, and social LCA methodologies to acknowledge the impacts from a better selective collection strategy that has been previously explained, evidencing the impacts on a better waste transport system, and all the impacts also from yield recovery fraction on the sorting stage. We are going to give some details and some data on Valencia study case, that it's the one that we have closer here from ITENE, but that can be applicable also for Utrecht and Alba Iulia and other European cities, also in case of replicability. So pass the slide, please. Yeah, so we start from the collection, and well, in this graph on the left, we can see some of the results from a better characterization from the citizens, from better collection. Main impact in this stage would be the reduction on the unwanted materials, and also the increase also of packaging materials in the packaging container, instead of in other flow streams as the general waste container, for example. And all these collection technologies, we are installing different sensors, we are installing different devices, and of course we move towards more technological work. We have also to keep in mind which is the impact of these technologies. So all these technologies used in PlastiCircle were also assessed. in terms of the use of NFC cards, the embed energy on the systems that we use. And let's say the good thing of this is that these impacts related to the technology that is being installed and deployed, it's very little in comparison of the amount of waste that is being generated, and also assuming the lifetime that these technologies will be used in the different locations. So we pass now from the collection to the next slide in also the impacts in the environmental state for transport and sorting. So in LCA methodologies, we assess many variables and environmental categories, but just to have a more close vision to which impact. So we all are more close to CO2 emissions, to carbon footprint emissions and climate change categories. So when we refer in this presentation to these impacts, we will mostly focus on this climate change category. And as you can see on these graphs, well, on Valencia pilot, the reductions in the pilot distances and the improvement on the quality segregation also led us to a save on 20 and 14% of the emissions of CO2. This without taking into account that all the plastic that is being recovered also has an avoided product in the way that we are avoiding producing new virgin materials, as I will explain afterwards. So next slide, please, Ariadna. Also, some studies that we did during the project acknowledge that when we consider recycled materials, the proportion of substitution from recycled materials to virgin ones is not one-to-one, because in the process, when we collect, transport, we sort, and then we process all this plastic, we have losses in the different stages, as you can see in this image later on the screen. So we assess these losses and the energy consumptions, all the resources that are used in every stage to assess the real impact of recycling plastic, and also to acknowledge where we have losses of material in the different stage. So in next slide, please, Ariadna. We can see that the blue bars make reference to the impact from the collection, transport, and sorting. So from the resources and from all the inputs that we use in these processes, and the green bars make reference to the avoided impact that we have from recycling those plastics. These numbers are referential, depending on the quantity of plastic that we collected from the pilots and other considerations on the washing and pretreatment. But just a referential value, we can save up to, on average value, 900 kilos of CO2 emissions per ton of plastic packaging recovered. What, in a more close sense, this could be equivalent to up to 390 liters of fuel consumed by any car or vehicle, or also this could be compared to more than 100,000 smartphone starts. So just to have a closer vision of the impact on recycling plastics. The idea is that we think further and we see the potential impact and the opportunity of increasing these yields on recycling, on the quality of all the processes, considering that, for example, a city like Valencia can produce more than 25,000 tons of plastic packaging on a year, which comes to our mind all the work that we need to do and that we are doing thanks to projects as PlastiCircle. So, next slide. We talk a bit about the environmental impact on the different stages on the process, but we also analyzed the LCC, so the cost structure and the money flag that there is in the recycling chain, together with colleagues from Sintef in Norway. And well, the main conclusions are that municipalities are the ones maybe more impacted from these waste managers. increasing the quantity of plastics in a city requires an investment for sure in these technological technologies, but these kind of investments are compensated somehow also by the reduction in the consumption and by increasing the number of plastics recovered. That this is translated in a higher remuneration by a PRO, for example, in the case of Spain and other countries in Europe. So these money flags balances between all the different stakeholders. Also knowing that there is a high pressure from European legislation on increasing, so in reducing landfilling and incineration rates and increasing the fees to do so, led us the unique opportunity to focus on increasing these recycling rates. Also knowing that these fees will be higher in the future. So. Also, just finishing maybe in this value chain, we have the recyclers that are maybe the link a bit weaker in this value chain because they are really affected by the price of recycled materials. It's important to stabilize the market and to find opportunities for recycled material in front of virgin plastics, which are highly dependent on the price of oil, for example. But in general, improving these quality flow streams directly affects the recyclers with better quality materials and reducing their operational cost. And so I finish with this this resume on the cost of the different stakeholders, and I give the turn again to Ariadna to give a bit more numbers on this. Thank you.
Thank you, Miguel Angel. Now we will continue with PlastiCircle business model, starting with the market analysis. When referring to total addressable market, the smart waste management market is expected to register a compound annual growth rate of 25.7% during the forecast period of 2020 to 2025. With this growth, the market is expected to reach $6.52 billion in this period, starting from $1.77 billion in 2019. Some of the factors responsible to the growth of the market are the increasing number of smart city initiatives and the proliferation of sensor technology. However, a lack of efficient connectivity can restrain the growth of this market. If we analyze the served available market, we will focus on Europe, with a population of 747 million inhabitants. The average of packaging waste generated in 2018 was estimated at 174 kilos per inhabitant. Referring to the serviceable obtainable market, we thought that PlastiCircle can target Valencia as the entrance to the Spanish market due to one of the pilots have been realized there, expanding the system to other municipalities in Spain, as there is an aim to continue innovating in order to find new formulas that adapt to the day-to-day life of citizens, helping in turning the municipalities to build responsible and sustainable localities. In the table, you could see some data about population and packaging waste generation in Valencia and Spain. The potential customers to PlastiCircle system are municipalities who want to improve their waste management system and waste management companies. PlastiCircle solution can work with current waste management systems without a huge infrastructural investment, as it can be adapted to the existing containers, trucks, and sorting plants. Waste management companies also could introduce any of the PlastiCircle technologies to improve their portfolio, as it is modular and compatible with other sensors and IoT platforms. If we look to other solutions in Europe for smart waste management, we see that there are relevant players in the market, with integrated systems with own-developed filling sensors, IoT platforms, and other digital solutions. They also offer to customers compensation procedures and pay-as-you-throw systems, and sometimes managing the sorting facilities. These players usually adapt their systems to the specific needs of the cities. There is also an innovative solution which avoids the collection of the containers using an underground collection network, connecting the containers with a waste terminal where the trucks collect the waste, avoiding pollution in the area. So which are the main strengths, weaknesses, opportunities, and threats of PlastiCircle? PlastiCircle solution is adaptable to different waste management systems, taking the opportunity to grow in countries with low recycling rates. However, there are a high number of competitors, and PlastiCircle has limited initial investment to commercialize the system. And how we intend to thrive. The incomes of PlastiCircle will be contracts and sales of the PlastiCircle system and sales of the recovered plastic. The incomes are projected to grow as the PlastiCircle smart waste management system will be implemented from Valencia to other municipalities in Spain, and finally penetrate in the European market. In the table, you could see the estimated incomes calculated. Customer base will be generated and expanded basically through referrals and inbound sales. If we take a look to the post-consumer recovered plastic, we could see a high difference between the quantity of plastic and packaging waste generated and the plastic waste recycled. So PlastiCircle could improve the quantity of plastic waste recycled, which could revert it in an increase of post-consumer recovered plastic for sales. Based on the cost analysis of the pilot implemented in Valencia, PlastiCircle solution will cost around €8.18 per inhabitant per month. Comparing PlastiCircle cost with the actual system, while collection will cost more than the actual system, the transportation cost can be decreased drastically using the route optimization and eco-driving guidelines of PlastiCircle, and the cost of sorting might remain the same. In the tables, you could see the cost of collection, transport, and sorting, and the total cost of goods sold. Otherwise, the percentage of plastics recovered rises up to 89%, with a purity of 91%, improving the classification of different types of plastics. These facts improve the quality of recovered plastics that will be sold to the recyclers. With all that gathered, we have realized a sensitivity analysis with different profitability margins and different levels of risk. As it can be seen in the table, in the worst scenario, the net projected value will be €257 million, assuming an initial investment of €3 million. In the optimist scenario, with 40% of margin, the net projected value is estimated to €1.3 billion. Comparing it to the actual system of waste management, PlastiCircle is not only profitable as the net projected value of the project is positive, but it is also economical. Finally, the last part of the project proves the utilization of post-consumer household plastic in added value products with applications in different sectors. We will talk about it deeply in the afternoon session. I will mention briefly the products developed in the project. The PlastiCircle products can be applied in building and construction, automotive, and houseware sectors, and integrates in their composition recycled post-consumer household plastics. These are extruded PET foam board by Armacell, laundry bags by Interval, ground reinforcement grid by Han, bituminous waterproofing membrane by Derbigam, an automotive bracket and automotive central console bracket for vehicles by CRF and Proplast. But there are other potential target markets for post-consumer recycled plastics. Shoes and clothing, houseware, garden furniture, landscaping, packaging products, collection units and bins, office supplies, roads, and leisure products like toys are expected to grow in the following years. With the increase of regulatory pressure to include recycled content in the products and with the aim to close the loop, we consider them as potential targets for post-consumer recycled plastics. At last, we are going to summarize the PlastiCircle outcomes. In the first place, the improvement in quantity and quality of plastic waste collected increases directly in the yield and purity of bales. Secondly, the smart waste management systems developed contribute in the reduction of environmental impact. Next, the cost-neutral recycling scheme for post-consumer plastics achieved with the collaboration of all stakeholders in different phases of waste management. And finally, we observed that the prices of recycled materials need to be stabilized to generate secure and competitive material flows. So thank you for your attention and your interest in PlastiCircle's sustainable business model to foster circularity.
Thank you very much indeed, Ariadna and Miguel Angel. Your presentation was extremely clear and very detailed as well about how the PlastiCircle approach can indeed be scaled out to a broader European market. Of course, the innovations are there, but now one might argue that all the work still needs to be done in order to scale it out and to scale it up. This morning we've heard a number of such issues. We've heard how, in the broader European context, PlastiCircle can of course slot into broader European objectives, decarbonisation, carbon emission, CO2 emission reductions, and of course in terms of circular economy objectives and the treatment of plastic packaging more specifically. We've also heard a number of challenges, notably the corona effect, notably that PlastiCircle, like every other project, has not been spared the impacts of a pandemic, and therefore readjustments have had to be made, and challenges have been presented to us. But we're going to hear more about that, I'd imagine, in the roundtable session later on this afternoon. But just as a quick reminder, and of course thank you for Ariadna for running that by us, we'll be dealing with the all-important issue of the added value products that PlastiCircle is bringing to market. Products that have been developed by PlastiCircle's industry partners, such as Axion, ProPlast, Armacell, Derbigum, the Fiat, or Centro Ricerche Fiat, as well as Han Plastics and Interval. So there are a number of products which are all the more interesting because they have used industry expertise from across Europe. And as such, the PlastiCircle project is a multifaceted project, and not just limited to smart containers, transport or sorting innovations, but producing real products, concrete products for market. And we'll hear more about those this afternoon. So with that, we can draw our session to a close. We will of course continue to endeavour to answer your questions in the chat, and we will deal with some live questions in the roundtable later, as I've mentioned. But until then, please let's reconvene just before 1 o'clock Central European time. So that's in 1 hour and 7 minutes, and then we will hear from Richard McKinley of Axion, who will take us forward on a journey of new products made from post-consumer recycled plastics. So please, we'll see you in just over 1 hour. Thank you. So good afternoon, and a very warm welcome to everyone listening in and watching from across Europe for this PlastiCircle Final Forum. I think it's time we get started after what I hope was a very pleasant lunch break. And of course, we have a very packed schedule for the next 2 hours, which is when we will close today's session. Once again, a reminder that you can follow today's proceedings with the hashtag, PlastiCircle Final Forum. So that's if you're following this on Twitter, on LinkedIn or Facebook, and please feel free to engage in the conversation that way. Otherwise, this afternoon, we should get on with the very important business of identifying the products, the very specific products from post-consumer recycled plastic. And of course, this is one of the strengths of the PlastiCircle project, and something which I know that our industry partners are very keen to share with you. And that, of course, will be followed by our roundtable session later on this afternoon towards the end of our day's proceedings. But first, if we could kick things off with Richard McKinley, who is the head of consulting at Axion. And Richard, if you would, could you please take the next 10 minutes to outline PlastiCircle's strategy to develop these new products? I know we're very much interested in hearing that. So, Richard, if you're all set, the floor is yours.
Yes, thank you very much. Okay, good afternoon, everybody. So I want to take you through Work Package 5, which is the development of the new value-add applications using recycled content from the PlastiCircle project. So I'll go through the aim of the work package, talk you through briefly the products that were developed, the methodology we followed in developing these products, and some results. The individual companies will be presenting after me, so I won't go into too much detail. I'll just give you an overview for them to follow on from. Okay, So the aim of the work package, this was focused on increasing post-consumer household recycled content in various plastics products. Some of the manufacturers already use recycled content, but largely from post-industrial sources, or in some instances from source-separated deposit return scheme material. So in all instances, we were trying to increase the use of the post-consumer household recycled content, which is an important distinction. By demonstrating the use of this recyclate, it means that it should increase the demand for recycled polymers from packaging. And if we increase the demand for the material, then it gives a whole economic pull through the system, which then helps to justify and cover the cost of sorting, collection, transport, etc. So it's very, very important to have these stable end markets. In PlastiCircle, we looked at 5 different products to increase recycled content within. So the products we looked at and the manufacturers thereof. So Armacell, who make a foamed PET board, which gets used in various construction applications. Armacell currently using coloured PET from the deposit return system. So here we were looking at more non-bottled PET sources and PET from the curbside collection. Derbigum, who make bitumen modified roofing membranes. So they use a certain amount of polypropylene in their product to modify the bitumen. CRF, who make automotive parts, again looking to include recycled content from polypropylene and PET. So quite novel, the use of injection molded PET in automotive parts, so you'll hear more on that later. Interval, who make various film products, so refuse sacks, laundry bags, aprons, etc. Looking to use recycled polyethylene film from household. Very different from film from commercial sources or film from agricultural sources, so quite a development there. And then Hahn, who make various products from urban furniture ground retention products. So this is an injection molded product that we looked at, which is currently made from post-industrial polypropylene. So looking at including post-consumer. And in this product, interestingly, we tried to use PP from film in this injection molded product. So the methodology we used, first off, we needed to define the product requirements. So for each partner, this was specifying things like the mechanical properties needed from recycled polymer, but also levels of contamination and what format the material needs to be in order to be used. When it comes to recycling, some people might be able to take chip, some people have to have it extruded and compounded. So the various partners had different requirements there. So when we defined the requirements, we're able to evaluate the recycled materials. In the project, we used current materials on the market, or largely on the market. So we were able to use products from state-of-the-art recyclers to test their polymer in terms of contamination levels and any other properties that are interesting to the partners. So, for example, Armacell needed to test the intrinsic viscosity of the PET and reactivity, whereas Derbigum needed to test the crystallinity of the PP. So quite different requirements for the end users. We then did lab scale development. So this is development on a couple of kilos of material to test the quality, to look at developing recipes for various additives, to then move into pilot or production trials. So once at the lab scale, the manufacturers had a very good idea of the quality and what additives were needed, then they were able to, at a much larger scale, produce parts or produce products, and then to test them. This gave them a lot of more information on how in the production environment material behaves and what settings are needed in order to use the material. We then did a final economic and technical evaluation. So the technical evaluation was looking at whether the product met the specification of the manufacturer and the end user's needs. And the economic evaluation looked at the cost of the raw materials, but also the cost of any additives and any differences in production process. So in some cases, for example, maybe a slightly higher temperature was needed or a different additive. So this can all affect the cost. I'm not not all cases was there a reduction in cost. Sometimes there was a slight increase, sometimes there was a reduction. So I'm happy to report that all manufacturers are able to incorporate post-consumer recycled content into their products, and you'll hear more about that shortly. But it was very successful. Like I said, there was a lot of work done to formulate these products and to test these products, and it's really good to see how it's been incorporated. So there's been a lot of R&D carried out in using these polymers into new long life applications. As I said, all manufacturers are able to incorporate more recycled content from a household source. In some instances, there was a slight cost increase, but we do expect that to change as more and more packaging is recycled and there is more availability on the market, especially for some things like non-bottle PET. We do expect that to change. But the cost increases were not hugely significant. There's a lot of ongoing opportunities here. So the work in PlastiCircle, it looked at 5 very specific products. And what we're trying to do is to say that these are instances of where consumer packaging has been used. And there are a lot more applications that could potentially incorporate more packaging recycling. So of course there is a focus on closed loop recycling, and oftentimes that is the best solution. So for PET bottles, for example, should be recycled into PET bottles. But for where there is maybe a difference in quality that it can't go back into packaging, these other applications could be interesting. And I believe that it should provide the impetus for other manufacturers to use more recycled content. That said, there is a lot of focus on putting recycled content into packaging, but this isn't always the most sensible thing to do. In packaging, it might increase the weight of the packaging. Food contact's always a concern. So companies using plastics should, outside of packaging, should also really look at incorporating recycled content. Currently, there is a slight economic barrier, largely within the non-packaging sector. If it isn't cheaper to use recycled content, then it's more difficult. So I think going forwards, legislation should look at focusing on not only encouraging recycled content into packaging, but also encouraging recycled content into non-packaging. I would say also for all these products we have made in this project, they are also recyclable. However, because they're often long life, they won't come back to be recycled for many years. So that's why they need to get recycled content sources from packaging also. And it's likely as well, if we are able to significantly increase the collection and recycling of packaging, that there will be a slight surplus of material, which is why we need these additional end markets. So I would like now to pass to my colleagues in the manufacturing sector to present the products one by one. And then I think we will be having a roundtable after that.
Thank you very much, Richard. That's excellent, very nuanced presentation, and very honest about the economic and legislative barriers as well that exist. So thank you. And that really does set the scene for this afternoon, starting with Marco Monti, who is R&D manager at ProPlast. Marco, can you hear us?
Yes, can you hear me?
Perfect, Marco. I believe you have a video for that. Is a video for us? Is that correct?
Yes. Well, just first of all, just a few words to introduce myself, to introduce ProPlast, because I'm here representing ProPlast, which is an Italian research center focused on plastics in general, and in this specific sector on the sustainability of plastics. In this project, from the technical point of view, we supported all the parts and most of the partners in charge of developing the products that Richard just showed you to all of you, and all the technical activities. But we were also in charge of preparing a video, which is a kind of exhibition of what we have done as developed recycled products. And so my speech is very brief. It's just for introduce you this video. And just to mention that this video just want to raise up your interest on the application we have developed, because afterwards, after my presentation, after the video, you will have the chance to. I listen directly to the companies, to the industries that produce this demonstrator, these products. So please, I don't know who is in charge of playing the video, but you can now do that.
Could I ask our colleagues at the ITENE to maybe switch on the video if you are able? Just bear with us a second.
Yeah.
Founded by the European Union's Horizon 2020 Research and Innovation Programme, PlastiCircle project has brought innovation in the entire value chain of plastic packaging waste management, to increase its recycling rate in Europe and to transform plastic packaging into valuable products. 20 European organizations have joined forces to reinvent the way we treat plastic packaging. 7 industries belonging to different sectors, 5 research organizations, 4 associations, and 4 pilot cities. PlastiCircle has rolled out innovation in waste collection, transport, sorting, and recycling. We developed smart containers to increase collection rates of plastic waste, cost-effective waste transport systems connected to Iot cloud platforms, innovative optical sorting technologies to improve sorting, and new value-added recycled plastic products. Different sectors and applications have been targeted. Interval is a Spanish producer of LDPE garbage bags, committed with the environment since 1982 by using post-industrial recycled plastics. In PlastiCircle project, Interval efforts have been devoted to the use of post-consumer PE. As a result, they were able to design a new bag 100% ecological for the laundry industry. Han manufactures over 2,000 products from recycled plastics for a wide range of markets. In PlastiCircle project, Han target has been to turn the feedstock from post-industrial to post-consumer recycled plastics. The efforts have been focused on ground reinforcement product. While trials are still ongoing, they've been able to reach the target for pedestrian applications. The Bigum is a Belgian producer of waterproof roof coverings. PlastiCircle has allowed the Bigum to find the best solution in terms of recycled polypropylene, to be used as a bonding agent in the bitumen formulations. Armacell is a pioneer in the production of PET foam boards based on 100% post-consumer bottle PET for a range of technical applications such as wind energy, construction, rail and road transport, automotive, as well as general industries. Within PlastiCircle, Armacell developed a foaming process to enable the use of recycled PET from a mixture of post-consumer bottles and trays. CRF within Stellantis is working to develop polymer materials with low environmental impact that are also economically sustainable. Increasing the use of recycled materials from post-consumer feedstock, reduction of polymer families and bio-based materials are the most promising strategies to be developed within pre-competitive research projects. Within PlastiCircle, CRF validated the use of recycled polypropylene and PET formulations on different technical components. ProPlast is an Italian research center with high commitment to the environmental aspects of plastics. Within PlastiCircle, ProPlast supported the development of the new products, with special focus on producing high-performance compounds based on recycled polymers that can be successfully used in the different sectors. PlastiCircle results contribute to the European Union's waste management and recycling targets to 2030 and are extremely promising for the transition towards an effective circular economy for plastics.
Okay, I hope you enjoyed. So I'll leave the floor to the next speaker.
Thank you very much, Marco, for bringing these products alive in our minds and in our eyes. Thank you very much indeed. And now, without delay, we can go to Armacell's Lisa Charlotte. Lisa. Floor is yours. I'm afraid we can't hear you at this moment. Maybe if you were unmuted.
Okay, now you can hear me?
Absolutely superb.
Okay. So you can see my screen now?
Perfect, Lisa.
Okay. Yes, so welcome also from my side. My name is Lisa Scholle, and I will present what Amacell has developed in the course of the project and regarding the production of PET foam boards from mixed sources of recycled PET and their potential applications. So before I present you the investigations and results in the course of the project, I will introduce you to Amacell, and I will close my presentation with presenting some potential applications of Armor PET foam boards. So who is Amacell and what do we do? Amacell is a global leader and the inventor of flexible elastomeric foams for equipment installations, as well as leading supplier of technical foams. There are two main businesses, which are advanced installations and engineered foams. And Amacell is represented by more than 3,000 employees in 23 production facilities in 15 countries. Amacell develops solutions for a wide range of fields and markets, but I will get to that later. PET Foams is a business division of Amacell and is fully dedicated to PET foam technology. Since 2010, Amacell has been pioneering in the production of recycled PET foam boards based on 100% recycled PET. Our diverse product portfolio of innovative, eco-friendly PET foam solutions is produced in 3 locations, which are Clermont in Belgium, Brampton in Canada, and Suzhou in China. Our PET foam products can be found in a range of technical applications, but I will get to that later. As mentioned before, our PET products are based on recycled PET. So how do we turn waste into valuable products? The post-consumer PET bottles are sorted, washed, and processed into flakes by the recycling companies. We at Amacell are using post-consumer bottle flakes to turn these into granules in our in-house granulation. And the granules are then further processed into foam boards, foam products like extruded PET foam boards, called Armor PET Struct, and after the use phase, our PET foam products are recyclable again. In the next few slides, I will present what Amacell investigated in the course of the project and what results were achieved. Today, we have already learned a lot about the different areas that the project has dealt with. At Amacell, we have been working on the characterization of recycled PET from different sources in order to define technical requirements and to develop recycled products. In addition, we have been working on the development of the recipe and process for production of PET foam boards with the aim of being able to use recycled PET from mixed sources, including trays. For the assessment of different sources of recycled PET on lab scale, we started with testing the IV and the CEG, which are the are 2 characteristics which are important for our process. And in each test, the tray material provided by the project was compared with materials from different sources, like virgin PET, PET from bottles with different quality, and tray-rich material, which is a mix of PET from bottles and PET from trays. The diagrams show the IV and the CEG results of the different materials, and both evaluations show that the quality of the tray material is worse than those of the other materials. The IV is lower and the CEG is higher. Important to be mentioned here is that the tray material provided by the projects is flakes, while all other materials are granules. So the values for the granulated tray material could be even lower for IV and higher for CEG. Besides testing the IV and CEG, the focus was on testing the so-called reactivity. This is an AMA cell internal test method that indicates whether the material is suitable for our foam extrusion process. The analysis of reactivity shows the same or an even clearer picture. The pure tray material shows very low reactivity on the left side, and the tray-rich material has also a very low reactivity. So when mixing PET from bottles with PET from trays, the reactivity decreases the higher the proportion of tray. You can see it in the graph on the right side. So when adding 20% of tray, only a fifth of the initial reactivity is achieved. The analysis of recycled PET from tray on lab scale show that processing the material is a challenge. We have to deal with lower IV, higher CEG, lower reactivity, and potentially higher level of contaminations with other materials. All this highlights the need to adapt the process and the recipe for processing this kind of material. Therefore, the next step was to test different melt modifier packages on lab scale in order to develop the best formulation. The graph on the left side shows the range of reactivity achieved for different proportions of additives and different ratios of different melt modifier packages, 1 and 2. Besides reactivity, the functioning of the additives and their effects on the mechanical properties must also be taken into account. MM1 will lead to degradation and reduced shear properties at elevated levels, and higher levels of MM2 will lead to cross-linking rather than chain extension. So taking all aspects into account, a combination of both melt modifier packages in a ratio of 2:1 with the medium total content of reactive additives has proven to be the best recipe. Based on the findings on lab scale analysis, the process and recipe for processing tray-rich recycled PET into foam sheets in pilot scale was developed. The target here was to achieve good mechanical properties of the PET foam board. At the same time, the process must be kept stable to avoid fluctuations in quality. The mechanical properties are strongly affected by the morphology of the foam. So to achieve optimal foaming conditions and obtain a homogeneous and fine-celled microstructure, the process can be adjusted by the recipe and the process parameters. The raw material for the foam board production on pilot scale was selected based on the screening and recipe development on lab scale. We used a tray-rich recycled PET with up to 20% of tray. As we learned before, PET from trays has a lower viscosity. Therefore, the use of melt modifier and the adaptation of the processing temperatures are needed to keep the pressure at a certain level and to achieve optimal foaming conditions. The upper graph shows the process pressure for different processing temperatures. Too low temperatures lead to high pressure and therefore to an unstable process, while too high temperature leads to low pressure, which makes the foaming insufficient. So the best results and a stable process could be achieved with temperatures of 270. The graph below shows the influence of different melt modifier, 2 proportions at 2 different MM1 proportions on the pressure. We developed a melt modifier formulation that allows to maintain melt pressure while preventing material degradation. As previously mentioned, a uniform fine-celled microstructure is crucial for good mechanical properties. Therefore, we analyzed the cell size distribution on foam sheets with different proportion of MM2 at 2 different MM1 concentrations, A and B. The more melt modifier added, the higher the numbers of small cells, which is better for the mechanical properties. And the comparison of the 2 graphs show that a certain basic level of MM1 is crucial. Besides the cell size distribution, the mechanical properties have been tested. The graphs show only a selection of all the tests carried out, just to give you an idea. And in the table, the individual test results of the demonstrator foam board are shown to give you also an idea of the values achieved. And again, a certain level of MM1 plus an addition of MM2 is needed to achieve good mechanical properties. So finally, we could prove on pilot scale that with a combination of adaptive processing parameters and new melt modifier formulations, it is possible to produce foam boards from tray PET that have a comparable quality to foam boards produced from PET from bottles. So provided that sufficient quantity of tray material of stable quality is available in the future, it is conceivable to use tray material for Armacell's PET products. This opens up the possibility of a new source of material and the recycling of difficult to recycle material that would otherwise not be reused. Finally, I would like to introduce you to a few applications. So as mentioned before, Arma PET products can be found in a range of applications such as wind energy, construction, rail and road transport, automotive, as well as general industries. So our Arma PET foam boards are used for rotor blades, for wind turbines, for body structure, for sports equipment such as surfboards. It is used in pedestrian bridges and walkways, like the Millennium Walkway in Derbyshire, UK. Another example is the jack tram for city, where Arma PET struct is used in the floor panels, or eco-friendly composite housing solutions like the one in the picture. For eco-friendly housing, Arma PET can be used for roof structures, for flooring, interiors like walls or doors, for facade claddings, or external thermal insulation systems. So that brings me to the end of my presentation. So thank you for your attention. And in case of any questions, please feel free to contact me or to raise your questions in the question and answer session. Thank you.
Thank you so much, Lisa, for an extremely thorough overview, and thank you for helping us visualize the really important applications which are obviously applicable to Armacell's products here. And of course, we move on to the next set of products, sustainable roofing products. And for that, we have Amandine Matagne, who is an operational R&D engineer with Derbigum of Belgium. So please, Amandine, if you're ready, the floor is yours. I'm afraid we still can't hear you. We can see you, but we can't hear you. No, still no. Try and see if you can unmute in some form. We can see.
Thank you. You muted me.
No problem at all. So we'll ask our colleagues to keep your voice active. So Amandine, please, the floor is yours.
Can you see my screen?
Yes, we can.
Okay.
We can see you. We can hear you.
Okay. So oh, sorry, I want to go back. Okay. So I'm from Derbigum, and I will talk to you about plastic waste in bitumen polymer blend. Sorry, for an ecological roof covering. So first we are talking about the company and what we are doing. After that, sustainability, thanks to PlastiCircle, what we have done, and some pictures on the roof. So the company was born in 1932. It counts around 350 people worldwide, and 200 of them are working in Belgium. In Belgium, we have 2 production sites, and we are using around 5,000 polymers a year. So We have an international presence. We are selling our products in Belgium, France, Italy, also United Kingdom, New Zealand, South Africa. So really in the entire world. What are we doing? So like Richard said before, we are making waterproofing membranes based by bitumen, some polymers, which are polypropylene polymers, and some fillers. The three of them, we called it a blend. So it is a bituminous polymer blend. Here you can see a picture of our polymers. It is contained in PE bags, which is important because I will talk about this later. To make our membranes, because they are not a blend, this is a membrane, we are using with blends non-woven reinforcement that can be glass reinforcement and PET reinforcement. Okay, about the sustainability, what we already did before the PlastiCircle project was to reuse the waterproofing membranes. We also use green electricity. We use recycled polymers before the PlastiCircles project, and we produce a system allowing the rainwater collect. So we already have this sustainability spirit. Sorry. What we wanted when joining the PlastiCircle project was to increase our percentage of recycled polymers because it's in our spirit, and that's what we did. So thanks to PlastiCircle, we have a real knowledge about the recycled plastics and recycled polypropylenes available in the European market. So we have tested 32 recycled polymer at lab scale. 3 were approved. So when they are approved, we are testing it at industrial scale. And just 1 post-consumer recycled polymer were approved. I talked to you before about PE bags, and 1 of the 3 approved at the lab scale wasn't on the industrial scale because it was contained in big bags, and this is something we cannot handle. And the other 1 wasn't approved because of the price versus quality. So we are currently using this post-consumer recycled polypropylene on the industrial scale, and this one, with this one, we can increase the volume of the recycled polymers from 850 to 1050. Yes, so we increase the tonnage of polymers a year. Yeah, it's yearly of 200 tons. So I show you some pictures on the roof. So I would like to say that it's important for Derbigum to increase our percentage of recycled polymers without degrading quality of aesthetical aspect. So of course, the finished product would stay like it was before the adding of recycled polymers. It's really important for us. So that's all for me. I think Mathieu will take the hand back.
Yes, indeed. Thank you so much, Amandine. And once again, it obviously helps for the non-specialists to visualize your products and to really see what happens on the roof. So thank you very much for that overview. That's excellent. But if we move from Belgium to Italy, because as you know, we have one of our partners is the Fiat Research Centre. And in that regard, I would ask Vito Lambertini, who is Materials Engineering Manager with Fiat Research Centre, to perhaps give us an overview of the applications in the automotive sector. Vito, can you see us? Can you hear us? Are you connected?
Yes. Can you hear me?
Perfect. Vito, the floor is yours. Take us into Fiat's work with PlastiCircle.
Yes, just a second, I try to share. So the screen, can you see the presentation?
We can indeed, yeah. Just put it onto the screen. Perfect. All yours, Peter.
Good afternoon, everybody. So yes, I will talk about the application and the results of PlastiCircle within the automotive sector. And this presentation, I will do the presentation, but a lot of activities was done by ProPlast within the project. So I will start with the introduction and motivation, why we need this type of projects. If you look at the breakdown of the material inside an example of vehicle and a C segment vehicle, we have more than 200 kilograms of material, polymeric material that are in our vehicle, divided by thermoplastic, thermosetting, and elastomers. And so this is a big issue for us. So we need to contribute in the reduction of the environmental impact related to this material, because we have basically three major challenges, three major drivers around this. The directive 2053 that relates to the end-of-life vehicle management, so recyclable material on our vehicle with constraints related to percentage of material, recycled material in our vehicles. The second is something that is becoming reality. We have already some directive and some restriction proposal within the packaging industry, and this is also in discussion about also for the automotive. And then the third pillars of the third driver of related to the circular economy is related to the lower environmental impact related to usually to bio-based or to recycled material. So all of these are really important drivers for us to work in the environment of recycled material. And the situation is not so simple for the automotive, because you see here the breakdown of the different polymeric matrix that we have. So you see that we have a lot of different materials, a lot of different type of matrices that are in our vehicle. The majority is the polypropylene one. That is the let's say the lower cost material, and then the most processable material. And so we are using a lot of this material, but also we have also increase the polyamide content up to 14% in our vehicle due to the technical requirements of some new components that we have. But the situation it's even more difficult, because we have usually we don't have only the matrix in our polymers. Usually we have a combination of additives, a combination of different fibers and fillers. And so at the end, what you see in our vehicle is really a plenty of different materials, different grades that are different grades that are in our vehicle with different specificities. So you see all the dots here in our graph related to polypropylene and polyamide. You see a lot of different grades, and so this is really an important issue that we need to face, because we have a really high request and very diversified request of materials. We already have something in place, so the state of the art is not clean from the automotive side, at least for the new Stellantis group. You see that we have already polypropylene standard. So we have already materials, you see in the center of the table, material that are already available and certified by our labs to be used in a certain type of application. At the moment it's a limited type, it's a limited amount of application, but in this case something is already possible. Clearly we need improvements in this side, because we need anyway stable performances. We need to increase the efficiency of recycling. We need to understand and to be sure that these materials are sustainable in terms of performances in time, and then we need new test procedure and new material standard to protect ourselves against not low quality material. And clearly we need also to be able to design product around these new materials. And so the situation for the PET is another material that is really highly focused in PlastiCircle. Today, PET is also some material that is already used from bottles. You see here some example of of application today. We have carpeting that are already based 70% of PET is coming from PET bottles as well. The real part of our Jeep Renegade is as well done in this way. Or the latest born in our vehicles, so the PET called the sequel, that is coming from the recovery of plastics from the sea. But today, no application, no big bulk application are present using PET in our vehicle, mainly due to the processing, the difficult processing or more difficult processing of this material instead of other well-established material like polyamide, for instance. And then what are the objectives within PlastiCircle? So basically, we want to adapt properties using two feedstock, both PET and PP. And so the idea is to produce bulk parts. So the idea is really to produce granules and to produce big parts in different application. We select two application, one for PP for interiors and one PET for the bracket for the engine compartment, for instance. And basically, what is really important that we decide to compound and to have 100% of polymer matrix coming from packaging feedstock. And then clearly after the production of the component, we want also to validate in order to see if the material is the component and the material could be ready for a potential production. And so the compounding phase started with the selection of material to be copied, let's say. And so you see that with PET, we decide to copy a typical polyamide 6/6 glass fiber 30% that today is not recyclable. It's not recycled today in our vehicle. We also did the exercise on PBT, so another polyester that is used for some specific application in our vehicle. And then we select for polypropylene 4 different grades of material coming from the quite difficult polypropylene talc 10 for specific interiors application, and then for engine compartment as well. And we selected the polypropylene with double fibers, double filler fibers and talc, and then other two materials, other two talc materials. So this is was the starting point. And then what we ask, we supply in particular ProPlast about our standards. So you see here some example of our standards. So the different numbers that are important for us to be met in order to produce a component with these properties, with the correct properties. And then we produced also what we did, we together with ProPlast, we select commercial PET from bottles. We also used PET from trays. We clearly compare this with PlastiCircle results, and also at the end of the project, we also wanted also to compare this with also post-consumer feedstocks, and then clearly for polyolefins as well, we start from commercial available materials. And so thanks to the work done in ProPlast, you see here the results of the different formulation of the 4 polypropylene materials, and you see that in most of cases, apart some minor value that clearly can be optimized with further optimization, we selected at the end the best one, that is the mixed glass fiber talc, as the one that reached the best performance. And so with this material, we produced the final demonstrator. Also for PET, for recycled PET, we start from the recycled PET from bottles. You see that there is a good match between the existing properties in PA66 glass fiber 30, and this is interesting because we had the same compound that was able to copy not only the PA66 but also the PBT, so the other polyester compound that we are using. And so for this, clearly, we did this on bottles. Then after the optimization, also we decided to go on trays. And so you see here the difference between bottles and trays. And clearly, you have we can see immediately that there is a good results in terms of use of tray PET that is comparable with bottle PET. So based on these very promising results in lab, we ask ProPlast to produce a certain amount of this material. Usually we ask for a pre-pilot of more than 50 kilograms in order to be able to produce parts, and we use the top formulations for recycled polypropylene to produce the demo one, that is the semi-structural part for interior application, and then the second formulations on PET, both trays and bottles, were used to produce the second demonstrator, that is a semi-structural part that is a generic bracket that can be used in several different applications. And so what are these two parts? So this the first part is as I said, is the interior application. This is the central console, so in between the two seats of a typical interior vehicle. Then the second one is, as I said, is a bracket that is widely used. It's one of the applications that can be really spread in our vehicle. So we have a lot of different brackets that are based on metals, that are based on PA66, that are based even in polypropylene in the different environment of the different areas of our vehicle. And then these were the two demonstrators that we produced. So the first one is shown here. So you see that it's really complex part, and so this demonstrates that the processability of this material is really high and is really good, and then it is possible to produce the part in an easy way without modification of the machine, only a slight optimization. And we did clearly some revalidation of this material. You see the different tests that we decide to do, like heat aging, humidity aging, thermal cycle, the measurement all gap and flash, and then also something that can impact on the bracket inside, that are based on the load, box opening, and cold impact. So you see here the device under test, and so at the end, what we can say is that we pass all the gap and flash analysis, and then we can say that we have a TRL5 pass, because we already have the material and components validated in real environmental application. The second device is the second demo is this bracket. So we for this bracket is a little bit more complex, because we have to change the injection parameters. So we don't have at the moment in our value chain suppliers that are able to pass from polyamide 66 mold to a PET1, and then we select with ProPlast one existing bracket that we have in our hands. So we were able to produce this part in the ProPlast lab, and you see the comparison that we did. So we produced the current PA. So basically, this is the application in production. Then we produce the compound, as I showed before, the compound using the PET from bottles, the PET from trays, and also the PET coming from the new recycle chain proposed by PlastiCircle. And here I summarize some of the results. So you see the bracket is mounted on an holder in order to do the tensile load test in real condition again. Also in this case before and after heat aging. And you see here on the right, you see here some example of results. And in the first picture, you see the comparison between polyamide recycled PET. So you see that respect to polyamide, that is clearly the material that was designed for this mold. We have a certain result that is very good, but we have also very good results with both PlastiCircle and also recycled PET from bottles from bottles that are really close, and so this the PlastiCircle one is even better respect to the current bottle grade that we tested. Clearly, it seems that the trays are a little bit in difficulties here. This is true if we consider not the optimization of the mold of the injection molding. If we optimize the injection molding, so at different temperature, you see immediately that also the material coming from trays became and behaves in the same way like the other. So also in this case, it's very important for PET to process it in a good way, and then this is clear that also in this case the recycled PET from trays, it seems in optimized condition really a good material. Also in terms of resistance to the different thermal cycles, so you see that basically this material is stable in temperature, so it's really well studied for the substitution eventually of polyamide, and then also you see that there are basically no difference before and after thermal cycle. And so these are just to summarize all the results, and also in this case what we can say is that also in real condition we have a similar behavior of recycled PET and PA, and as well in this case we can say that TRL5 for this specific component is reached. Then some conclusion. So have you seen that we optimize formulation for both recycled polypropylene and PET from packaging feedstock? We succeed to do it using 100% of the polymer matrix based on these feedstocks. This is really very important results for us. We produced two demonstrators, the central console and the bracket. We validate both components in vehicle condition, and so at the end the result is that okay, the recycled polypropylene performed well as let's say expected. The recycled PET from trays is showing comparable results in respect to the bottle grade, and here in this case we have to say that there are a lot of further improvements in this type of material, and so this is really promising, as well as the PlastiCircle recycled PET show even better performance in higher stability respect to the counterpart we measure. Also, I mentioned at the beginning, and so we produce also some benchmarking of different feedstock and also of some compound based on post-consumer recycling, and we can share this information privately in order to see the final results also with this comparison. What I have to say in terms of further activities, you see here that based on the cake that we see at the beginning, so we need really to go further, and so we launched during the project also this campaign, this big campaign, in order to substitute not only the grades that I show that are belonging to PlastiCircle, but also we decided also to enlarge the number of grades potentially available on the market, and so we also interact with a lot of different suppliers in order to understand if they could be able to copy and to make the same grade, the other grades also for suitable for automotive market. And so at the end, what we have seen that there is a lot of activities around this. So a lot of suppliers are working clearly at the moment in this. And so the final objective for us will be to enlarge the polypropylene and polyamide standards in order to answer to the first request that I presented at the beginning, saying that we need new standards to be able to accept this type of material, to be sure about the quality. And then clearly the next step is to present these results to the material provider, and in order to understand their interest in in-source the results from PlastiCircle. And clearly what is very important for us is also to start a discussion with the Taiwan, so with our component producer, in order to leave them to increase also their experience to treat and to process not only polypropylene that is already in their hands, but also to treat poly PET in order to be sure that they will be ready to substitute at a certain point also polyamide grades, especially in this period where we see a lot of problems related to shortage, clearly this activity could be really important to overcome or to solve or to help in solving this issue. And so with this, I would like to thank you for your attention.
Thank you very much, Vito. That was a tour de force. We covered a great deal in that presentation, and it was particularly interesting to hear what Fiat's expectations are from legislators, from projects such as PlastiCircle, etc. So if we move from yourself, Vito, thank you so much. Please stick around for the round table where we'll have more questions from the audience. And now if we can move on to yourself, Howard. Howard Waghorn is the director at Han Plastics Limited, and there are also a number of applications in your sector that PlastiCircle has been able to contribute to. So please, Howard, the floor is yours.
Thank you, Matthew. Let me bring up the presentation and check that you can see it first of all.
No problem. We hear you well.
Okay, excellent.
And presentation, just a sec. Yeah. Perfect.
Perfect. Good. Well, firstly, let me just reiterate a couple of the comments that Richard made earlier, that PlastiCircle is really focusing on post-consumer plastics. As a manufacturer of products out of recycled plastic, post-industrial is relatively easy to work with. And as Richard was saying, by producing more products from post-consumer plastics, we can get a pull-through of demand that resolves many of the problems of processing the material and making it useful to use. So that's really the focus of my presentation today. Apologies, I need to go back one. So I'm going to take you through the current use of recycled plastics, particularly from a harm perspective, and where we were able to break some new ground within the PlastiCircle project. And then finally, some thoughts about current and future applications for post-consumer waste collected from PlastiCircle and from other projects as well. So firstly, a little bit about Han. Han has 8 locations across Europe and North America. And last year we processed 74,000 tons of waste plastic, converting that into over 2,000 different products. We do use post-consumer and post-industrial, but the bulk of it is post-consumer, so over 2/3 of the material that we use is post-consumer. So it's already a valuable commodity in some areas. So where you'll typically see it is applications like outdoor furniture, which you'll commonly see in parks and outdoor spaces across the world, quite frankly. Increasing use in applications such as fencing in both urban and rural settings, with the big advantages being that there is no maintenance and no need for replacement. Obviously, these products are historically made from timber. Timber will rot in outdoor environments, and of course, plastic doesn't. And increasingly commonly used now in wet and harsh environments where wood decays very, very quickly and will rot. So from a municipal perspective, to be able to install a boardwalk or walkway like this that requires no annual maintenance, no treatment, is a big advantage. And these are all now made from post-consumer plastic wastes. So within the PlastiCircle project, then, we wanted to find a challenge of a product that was currently made from post-industrial and just see how we could use post-consumer waste to create that product. So this is what we call a ground retention grid. So it's typically used for vehicular access. So it's used for car parks and driveways, etc. And the big benefit of this is that it complies with sustainable urban drainage regulations. So In heavy rainfall, the water will seep through the grid and the gravel nice and slowly, rather than hitting the storm drains very quickly, as you tend to get with heavy downpours, particularly in cities where the majority of the areas are now concrete or asphalt or solid areas. So we attempted a project that was to convert this product to use as much post-consumer as we can. In this post-consumer material, we're using a polypropylene film, which is commonly not used from post-consumer waste at the moment. So it did present quite a technical challenge. So we started off by attempting to make a product from 100% post-consumer, and then we've reduced the percentages to see if we can find the right balance to be able to make it cost effectively, but from that lower grade. We started, as I say, at 100%, reduced it to 80, reduced it to 70, and finally settled on a 50-50 mix between post-industrial and post-consumer that was working quite well for us. So at this level, then, we were able to produce products with reasonable effectiveness, and we went through the testing regime appropriate to this type of product, and we were able to pass all of the deflection tests. Clearly, it's a product that vehicles drive over, so its strength is critical. The connection test, the grids are connected together, and therefore there's a pull test to ensure that they don't separate in use. Loading test, which is relatively easy with plastic. Obviously, it's very strong under compression. But at this stage, the product has been a little bit too brittle to be able to take full impact. So there is still some work to do there. But I feel confident that we will end with a sensible proportion of post-consumer waste in the product. But it is challenging given the inconsistency of this particular grade of raw material that's not generally collected. But some thoughts really on the use of post-consumer waste in other applications going forward, because Han, for many years, 28 years of producing products from recycled plastic, has been driving the way in the use of this type of product. So we've developed a large number of products over the years, some of which do require in-country approval, but many are in existence and simply need communication and widespread use to get full acceptance. So I think the product in the photograph there that's commonly used now for truck parking across most of Europe is a great example of that, and we're starting to see the growth of this product now across the rest of the world. But the applications are almost endless. If we look in infrastructure, you can see that we're starting to be used in rail. We're starting to be used in civil engineering, and both of these applications are post-consumer waste. If we look a little further afield now, the picture on the left is a green street in Montreal, Canada. So the Canadians really moving heavily towards the acceptance of these types of materials in vehicular applications. So that particular street is 6 or 7 years old now. It's been through Canadian winters and Canadian summers, and it's driven up and down by garbage trucks and snow plows, and it works very effectively, and we're starting to see the spread of that use. And on the right-hand side, this is one that's a combination of post-consumer and post-industrial, because for a domestic driveway, you're looking for something slightly more aesthetically pleasing, and from post-consumer, it's quite difficult to get that. But increased use, again, in the more harsh climates where concrete will break down very quickly, recycled plastic is proving to be a very good alternative. And the final thought of some retaining wall structures that we've developed here in the UK. Again, a blend between post-industrial and post-consumer, but these now have British Construction Board approval, fully tested with a design service life of 120 years. So that actually moves recycled plastic into a better construction material category, into a zone that's better than some of the alternatives that already exist. I mean, I quite strongly feel that there's really no limit to the innovation in terms of what we can do with recycled plastics. Probably the biggest challenge that we face is the acceptance of the applications that are generated in a very traditional European market. Thank you.
Thank you very much, Howard. Once again, visually very, very impactful and very inspiring to know that, of course, these products are in the market and that some of them last for 120 years. But of course, as you say, much work on public acceptance to be done. But thank you very much, Howard. Please stick around for the round table, because a number of questions are coming in for several of you. We'll get to those in a few minutes. So if you could please join us for that, that'd be great. And yes, since we're doing well on time, then of course it would be good if we could move on to Eva Garcia's presentation. Eva Garcia from Interval, who of course have been producing 100% recyclable garbage bags. And of course, if we move to your presentation, Eva, again, we're doing well for time, so that means that we will have more time for questions from the audience at the end. I would very much hope so. So please, Eva, take it away, and please tell us about Interval's production of 100% recycled plastic bags. Thank you.
Thank you, Matthew. Good afternoon, everybody. I'm going to show my screen. Can you hear it? No.
We can hear you, but we can't see your screen. That's better. Perfect.
Thank you very much. First of all, good afternoon. My name is Eva Garcia. I'm the business manager of Interval. We are one of the industrial partners of the project PlastiCircle. We are the ones that work with polyethylene. First of all, I'm going to explain our summary. The first, I'm going to talk about who we are, our target here in PlastiCircle, and which is the innovation that we have done in the project. Let's go. All first, who we are. So Interval is a Spanish plastic industry born more than 35 years ago. We are a small enterprise. We have 13 employees. And actually, the company is running for the second generation of a business family. We manufacture 4,000 tons of low-density polyethylene by year. And this is the only kind of material that we work, polyethylene. Our product lines, we have 4 different lines. The first of all is the production of pellets or low density in natural and black, are used in our factory or sell to other converters. The second is films for packaging industry that could be sell like bobbins for other industry for print or code to our customer facilities. Other of the lines of the Interval production are the garbage bags for waste management, for example, for the cleaning industry or for maintain clean the streets, like John Saab, for example. And other product that we are working is a line for food industry that we work only with virgin material. This is the material that we work when we are talking about with the 3 lines, the pellets, the film for packaging industry, and the garbage bag is polyethylene for recycler. The origin of the material is basically in these 3. Industrial is waste from another plastic factory For example, rare for the production and other films. Other kind of the origin of the material is commercial, waste from supermarket packaging, for example, the cover of the plastic for the logistic. And the last one is the agricultural, the greenhouse cover, for example, for the tomatoes crops. The last one, the commercial and the agricultural, are post-consumer materials, are considered as for consumer. In our process, we have two different plants of productions. Here in the recycling plants, we transform waste in raw material, and depending how dirty is the material, so we do that selection, as red, a wash, extrusion. And later we have a fill plant where we melt the pellets and give a new life to the plastic, and we have one part that is the extrusion, where we can give the color, the thickness of the material, depending on the bag or the final product that we want to do. And other of the process is the cut that could be, for example, in rolls for the garbage bags. Which is our target in the project? First of all, is introduce a new material. It's in this case is a photo of a household, and we have to face with different qualities that we used to do with the agricultural or with the supermarket products. Here we have to solve some problems. First is the mix of materials, impurities, odors, multi-layer materials, food fragments, different density in the same bags. So how we have to solve it? This is for us the main step, an excellent sorting, because for us, this is the best way to obtain the most valuable material and avoid a lot of problems in the future in the process of the polyethylene, which will be which was our next steps, the production in our plant. We try to mix different percentage of post-consumer that we usually work in the interval with household pellets, and with different kind of percentage we can obtain 100% material with recycled material and with a thickness of 20 microns, that for a garbage bag is a very, very good quality. And at the end, we can obtain a roll of garbage bags. And if our customers can get with our materials an ecological product with Blue Angel ecolabel. Next, innovation. Here it's how can we improve to make a product, make it easy to use without no risks, avoiding using virgin material, and also more competitive? How can we obtain it with innovation? In next step, we have done a collaboration with a French company named Labtips, and we developed a laundry bag made with a mix of materials. This for white side, it's 100 low density polyethylene recycled material from domestic packaging with degradable material. It's a water soluble type. It's a biologic resource. It's with protein, and with the mix we make a laundry bag for hospitals or for applications that are, for example, for nursing homes, all these kind of things that must be control the contaminated environments. What is the solution that we obtain with these bags? Limit the risk of the contamination of the laundry circuit cloths, easy to recognize and separate from the rest of the lingerie, no water impact, no sticky residues and microplastics, and fast deliverable. All the materials are from European manufacturers. Here there is a video that shows how it runs, but it's very important that you see that these materials are the plastic 100% from household material, and later is a mix with a biodegradable material. I'm going to show you. This is a guide of good prices of industrial laundry to avoid contamination risk. First, you have to identify the clothes with the potential contamination risk. In this case, with the recycled bag is red. Using this bag, you avoid the clothes contamination too. Close the bag with a sellable tie and put the bag inside the washing machine. You select the program, and it is possible to wash with cold water. In a few seconds, the tie disappears and the bags open. Once the program finishes, take out the clothes and later the bag. It is ready and clean to be recycled again. No plastic pollution to the sea. And this solution is actually running in the Spanish hospitals. So this is all. Thank you very much for your attention. And here in Interval, we are at your disposal for further information. And this is my email, and I will be glad to help you if someone wants to know more about the project or how to introduce the polyethylene in the garbage bags.
Thank you very much, Eva, for your presentation and for giving us, again, very visual run through of the applications and the uses. Also wonderful to see that these bags are being used very widely in hospitals and in the health sector. So thank you very much. And now at this stage, if we could perhaps move on to the questions from the audience. We have been receiving a number of different queries via the chat function. So in that regard, I think before we open up the questions for you in the audience, and of course to do that, please raise the hand in the chat function, and then we'll try and address as many of your questions live as possible. But before we do that, I think it would only be fair if we addressed a couple of the queries that people have been very patiently waiting to hear answered, because they've posed those in the chat function. In that regard, I have a question for Vito. So Vito Lambertini of Fiat Research Center, and you have received one question. I'm afraid I don't have a name for you, but this person would like to know what the main obstacles are to use recycled plastics in the automotive sector. So perhaps I think perhaps you will have three or four obstacles to recycle plastics in automotives, Vito. Could you please run through those for our audience? But you'll have to unmute yourself, I'm afraid. We can't hear you. No, I'm sorry. Please try again.
Now it's okay. Okay.
Yes.
Okay. So. Yes, so the first very important obstacle is a technical obstacle. So for sure, from the we need a stable performance. So the automotive market is really a huge market on one side, so it's very promising in terms of business. On the other side, clearly we require very stable material in tons, in different lots, and so this is one of the main requests that sometimes could create some issues even with virgin material. And so we can imagine that with recycled materials, this can be even a bigger problem. Then for sure, what is important is something that is related to cost. We are seeing a strange trend in the recycled material. So since a few years ago, recycled material, mainly for post-industrial, were really considered lower cost because the feedstock was really low cost. Even if the quality was not bad as maybe in mind of customers. But anyway, this is something that we see, and so we must be able to work really on in the way to increasing clearly the application of this material. We can imagine to have also improvements in terms of recycling, in terms of sorting, in terms of all the optimization of process to have lower cost on one side. And on the other side, in our hand, we have the design. So we need to be able, and we need to improve the design capabilities for circular economy. So it's important for us to do this in order to have better design of components to be maybe easily to be disconnected at the end. We need to have a good design in order to overcome maybe the technical problems of this material. And so we need also for sure to improve internally. Then it's very important to be sure of that this is related to quality. We need to have the quality control that is very important as well for this material, and this is a lack. And this is in general from the technical point of view. From the legislation point of view, it is clear that we are speaking of recycled material. So we need anyway to have all the legislation and all the environmental, so all the directives and all the legislation that we must meet in order to be able to put this material in our vehicle. And clearly, this is something that is growing as well. So we have a lot of suppliers that are claiming, or they are trying to get this type of approval from some certified lab and so on. Something is ongoing inside PlastiCircle to cover also this part at the end of the project. So it's something that could be an obstacle in the future, but at the moment on the other side we have a lot of push in the application of this material that for sure all the legislative and technical issues I think that will be overcome soon.
Thank you very much. Thank you very much, Vito. I believe that probably answers the question. And very quickly, I think we had another question for Amandine. So Amandine, there's a question for Derbigum. Can this recycled plastic used in bitumen polymers blended waterproof roof be recycled again? So we're talking about the bitumen polymer blended waterproof roof, and can this material be recycled again after, I'm assuming, after this use?
Yes, of course. It's already the case because, like I said, we recycled for so many years now the roofing membrane, so included the polymers content. So we have at the company, at the factory, an entire department for the recycling of the membranes. So the recycling of the membranes is the recycling of our waste production, of some waste on the roof. When they are cutting the edge of something, we are collecting it and recycling it. And we are also recycling old roof. So a roof, when you make your roof, it's maybe for 40 years. And then after that, there are some demolition. We are taking it back and reusing it again. So yes, recycled polymers are recycled again.
Thank you very much, Amandine. That's a very clear answer. And now if we could go to, I see a few hands raised, or rather green question marks next to your name. And if we could start with Alberto Deo, because Alberto has been waiting patiently. and has a very specific question. Perhaps Richard McKinley can help us with this. Albert, would it be possible for Albert to switch on his microphone and his video? Would that be possible, ITENE? I'm not seeing any movement on that front. Just to confirm again, would it be possible for us to, on a case-by-case basis, open up microphone and video for the attendees?
Hi, good afternoon. This is Albert.
Hello, good afternoon, Albert. Thank you for joining us. Yes, please feel free to ask your question.
Okay, my question is about REACH regulation. REACH regulation is something that has to be mandatory for all substances and materials that we put in place in Europe. And the question is about recycled plastics, because we have tried to find a lot of suppliers, even the big ones like ExxonMobil or INEOS, Borealis, whatever supplier that provides us with polypropylene or polyethylene with recycled material, and no one of them are able to certify that the material is compliant with REACH in terms of absence of substance of very high concern. Okay, and my question is, okay, if we are not able to provide this certificate to our customers, how can we improve the number of materials or the products that we produce in post-consumer recycled materials?
And can I ask you, who would you like to direct that question to? Would you be willing to take this on, Richard?
Yeah, probably for the.
Yeah, Richard, please feel free.
For the European community, I can't remember the name of.
Yes, so that would be Yanis.
I'm here now.
Sorry, all right, Rick.
Automatically muted.
After you, Richard.
Yes, I'm not a REACH expert, but I can comment a little bit on it. As far as I understand, especially when we're talking about packaging recycling, the assumption is made that all the packaging that is recycled is REACH compliant already, as it's such a short life product, and so the resulting polymer should also be REACH compliant. And there is a, I think the term is read across, which means that recycled polymers can be REACH compliant. So I think from a point of view of REACH, it should definitely be possible to use recycled content. And again, it definitely more so for recycled packaging. If you're looking at recycling some very long life application products that may have been in circulation for 15, 20, 30 years, and that becomes much more difficult, and they are much more restricted in what you can do with it.
Okay, then you mean that all the materials that are recycled, we can assume that are REACH compliant?
Yes, the recyclers should be able to confirm that it's REACH compliant. They may be able to do testing, and some testing is not too expensive, depending on what they need to do. But yeah, they should. The recyclers should have REACH compliance.
Yeah, the testing of there is now 211 substances in SBHs, and the testing it's very, very expensive, I think.
Yeah, but again, it's you can also use, for peace of mind, auditing trails, for example, to see where the materials come from. If it's come from household packaging recycling, then like I said, everything that went into that process should be REACH compliant already.
Yeah.
So if the recyclers handling that material, it should be okay. But if anyone else has any contracting opinions, please feel free.
Any other thoughts? No. Okay. Thank you, Albert. Thank you, Richard. We have certainly about another half a dozen questions for the panel. If we'll start in reverse alphabetical order, I think we can start with Wan Ting Su. So please, ITENE, if you could please arrange for Wan Ting to have the microphone unmuted. Wanting Su, can you reach us? Yeah. Again, I'm not seeing any movement there. So
Hi. Hi, can you?
We can hear you now, Wanting. Please, if you could briefly ask your question. Thank you very much.
Oh, okay. I have a questions about I want to know what's the percentage of the recycled plastics used in automotive sector.
Okay, thank you, Wanting. Would there be anybody who could hazard a guess? I probably think that would be a complex question, Vito.
Yes. This is a really bad question because okay, it's something that is so it's always under debate. What I can say is that there is a big difference between the different OEMs, and basically the ex-FCA side never published any type of detail about this, and so clearly I cannot share what is the percentage at the moment. What I can say is that if you look in some presentation from other OEMs, even from now the new also the new colleagues from XPSA, so there are percentage in different OEMs that are coming from 20 to 25% claimed in 2025 to be to use recycled material. Clearly, this is something that is feasible in terms of technically is feasible. So there are kilograms of material that can be substituted by this material. Is it clear that everything that I saw before is valid? So we need a strong value chain. We need a strong commitment from the company to do it, and also for sure it will help also some specific requests from the European Commission that will be done. So basically, the answer is that I cannot answer. Okay.
Okay, thank you.
But let's say the percentage when you have 20 to 50 kilograms of recycled components in car, this is something that is something that we can for sure make as possible. Then European Commission is working with the ASEA group, with all the platform, automotive and transportation platforms in Europe to decide how to proceed. And is it clear that it depends a lot how the request will be placed? If we have only to consider polymers, if we can consider also the filler, if we can consider I don't know, green material or degradable, biodegradable material, bio-based material. So if we can consider regrinded material, so all these questions today are not answered, and so it's difficult to. It really can be a really wrong figure that I can say about this.
Thank you very much, Vito. Thank you. And without any delay, we'll move on to Simona Biolo. So Simona Biolo, I believe you had a question for the panel. ITENE, could you please connect Simona Biolo? Once again, we're having a slight delay moving forward to the questions.
Hello, can you hear me?
Hello, Simona. Yes, we can hear you. Please, please proceed with your question.
Yes. I'm working in Plastipack. It's a company that produces PET resin and preform as well, and I'm very interested in chemical recycling. So I would need some additional information about this process, and in particular way, what is the legislation position about the material coming from this kind of process? Because as you know, EFSA, in terms of mechanical process, everything is very clear. And but for chemical recycling is not really defined and clear for us. So I don't know if someone has some additional information about this, and someone can help me to understand better.
Perhaps. Thank you very much, Simona. As we said earlier, I think chemical recycling is not really the focus of the PlastiCircle project. Perhaps Miguel Angel or Eva Garcia, perhaps do you have any information? Perhaps you know of any resources that Simona could go to for more materials.
Hi, can you hear me? Yeah.
Yes.
Yeah, well, I think that this is a big question nowadays. Like, it's in the spotlight for European study cases. So giving an answer on chemical recycling in general, I think is not that easy. There are many factors. Many people also trying to make it feasible in terms of economical and environmental way. But I mean, it's not the focus from PlastiCircle. We focus on mechanical recycling.
Yeah.
Anyway, afterwards, I'm sure we can share maybe some information on some European maybe guidelines or something. But I guess there's not a unique answer for chemical recycling, I'd say.
Okay, thanks. Everything you have it, please share with me. I understood this not focusing in this PlastiCircle, but in any case is a part in order to recover waste, plastic waste, in the sustainability process.
Yeah.
For the future.
Yeah.
Yeah, sure.
Thank you, Simona. Thank you, Simona. Maybe if you can get in touch with me, then you might be able to find some answers and some more information.
Yes.
Right. Could we move on to a question by Pedro Gutierrez? Pedro, I'm not sure if you can hear us, and if so, can we connect Pedro Gutierrez, please? So once again, this takes a minute. Please bear with us.
Okay, right, no? Can you hear me?
Yes, we can.
Yeah, perfect. Thank you all of you for your presentations. Really nice work, and really nice to participate in the future of the circular economy and this problem that we have in Europe and in the world. My question is about how many times can you, with the industrial processes, recycle the same plastic? For example, one item, how many times can enter into well, the process, no, to make another new item and new life. It depends the plastic. It depends the process, the life, the use.
Thank you, Pedro. Do we have any brave volunteers for this question? Marco Monti of ProPlast.
I can try to answer to this question. I mean, there is a lot of studies in the scientific literature regarding how many times you can recycle plastics, and well, there is not a precise answer, not even refer to a single plastics, because we know that every kind of plastic, every type of plastics degrade faster or slower depending on this nature. For example, polyolefins are very good in recycling many times, polyester less, surely less. In that case, well, you can use additives to stabilize the polymers when you recycle more time. That's one way that you can follow to save the recycled plastics. Mixing virgin plastic with recycled plastic could potentially help to stabilizing the performance when you're recycling the polymers. So there are many ways to make the plastics 100% recyclable every time, because this question is very important. It's true that many people are asking how many times you can use recycled plastics, especially now when we are going to 100% recyclable products. which will be very technical challenging. So yeah, more or less it is all this is an answer which does not finish the topic, but you know, it's something that we are studying. So
thank you very much, Marco. Would anyone else like to weigh in on that particular question? Nope. Okay, fine. Very good. Right, if we could move on to a question by Gianmarco Giacomelli. So Gianmarco, if we could just activate your microphone, that would be really helpful. So that's Gianmarco Giacomelli. And again, just bear with us a second while we do this. Gianmarco, can you hear us? And I believe that Gianmarco is from Aquafil. That's the company in question. Gianmarco, I think you need to unmute yourself. Have you done that? No? Okay, we'll come back to you, Gianmarco, if that's okay. And if we could move on to Sriparna Das. So Sriparna, I believe you had a question for the panel. Can you unmute yourself? Can we unmute you? And can we connect you? Because we need to move on with the questions. Sriparna Das, can you hear me?
Hi there. Can you hear me?
Yes, we can.
Okay, actually, mine was not a question. It was kind of an answer to Simona, who had a question about chemical recycling. And I wanted to add my 2 cents. I don't know if that is what is the current standard. So from what I understand, companies who are producing grades from chemical recycling are going for a certification called the ISCC+. And that's the certification that they're taking currently to certify their polymers as circular grades. But I don't know if, of course, there are still a lot of question marks for chemical recycling and products being, with the legislation. So just wanted to give my 2 cents.
Okay, thank you very much, Sriparna. Thank you very much. That's much appreciated. And let me see, I'm just in contact with my colleagues and we're trying to get a hold of Gianmarco Giacomelli. Can we connect with you, Gianmarco? No? Okay, in which case I would like to open the floor for any other questions before we move on to the closing session of today's proceedings with César Aliaga of ITENE, who of course is the project coordinator. And I'm not seeing any other questions. So in that light, what we'll do is we will close the session, and we'll also make sure to get back to you, Gianmarco, if you have a question which you would like to pose to the panel. And of course, that goes to any one of our listeners today. If you have any burning questions or issues that you would like to see followed up, then we'll endeavour to do that over the coming days. Right. So thank you very much. Thank you to all the panelists. Thank you for your time. And not just during this roundtable, but of course during the day itself, and of course over the course of the project, because now we're going to move on to the swan song of the PlastiCircle project, which is of course the closing session of today's final forum by César Aliaga. So César, are you ready? If so, the floor is yours. And once again, César, you'll need to unmute yourself.
Yeah. Hello, Mathieu. Can you listen to me now?
Perfect, we can hear you, and after a very informative roundtable session, you're what's left between now and the end of the PlastiCircle project. So please, César, take it away.
Okay, thank you very much, Mathieu. Okay, so it was really a pleasure to have you all in our event. So I want to thank you first of all, Mathieu, for this nice speech along today. Also to all the panelists, I think we had a very nice presentation from all of you, and of course from all the attendees. It was really an adventure for us, this final event. We were many people connected, more than 300 people connected. So this is really, so we are really glad of this, about the impact that this project is having in Europe and in all the companies. So thank you for that. Thank you for your interest in our project. And now, as we were commenting all around the day, the technologies are ready. So we have been working a lot during those four years, more than 20 partners working jointly in the different areas of collection of waste, plastic waste, collection, transport, sorting, and recycling. So now technologies are ready. Also, the project is about to finish. We will be finishing in May, so only 1 month left for finishing. Actually, we have our final internal meeting in some weeks, and also with the Commission, with the European Commission. So we are, let's say, finishing the project. So the challenge now is to really go to the market with those technologies, because our aim always is not to finish with the research inside our facilities, but also to spread all the technologies in the market and to make a difference. So this morning we were discussing about the problem with the plastic packaging. So it's a problem, but it's also an opportunity for all of us to make businesses on it, to make it better. Yeah, we are really wondering to have the contact with you all, to start new businesses, to start new opportunities. So we are here for your help. So please contact us if you have any doubt, or if you want to move anything with us in the area of businesses, and also in the area of new European projects, because I think that was a really open project dealing with many different technologies, but also we have to follow with the research in the areas of plastic and packaging. We have many things to do. Still, we have many packaging materials that are not recyclable. So we have really a lot to do in the following years in order to fulfill all the requirements from the European Union. So we are really happy with PlastiCircle, but we are really wondering to do new activities, new projects, new businesses, new activities on packaging and on plastic recycling. So thank you very much again to all of you, and keep in contact. All the best. Bye.
Thank you very much, Cesar. I think no one really could have said it better. The fact that there is indeed much work to be done still, despite the fact that you are coming to the end of this PlastiCircle project. And I'm sure everyone would join me in offering a warm congratulations to all 20 partners in this PlastiCircle project, especially under the leadership of ITENE, and especially under your leadership and your team at ITENE as lead partners. And I'm sure everyone would agree that you deserve warm congratulations for the work. But of course, at European level, the work continues in circular economy and plastic packaging. And all that remains to be said is watch this space, because there will be activities, and there will be programs, and there will be initiatives aplenty in the coming years at this critical time for the circular economy and for the environment. So all that remains, I think, is to thank all of you today for joining us during this PlastiCircle Final Forum. And I'm very glad to see that our speakers, our participants are coming back online, because, and I'm not sure if this is technically possible, we would like to do a family photo with as many of you as possible using the very sophisticated means of screenshots. And we're going to take some screenshots of as many of you as we can. So I'm not sure if the attendees, if all of you who have been kind enough to join us here today, will be able to put on your cameras. If not, that's okay. We have the speakers, and please, I would ask all of you to switch on your cameras so that our respective communications teams can put some faces to this project and to this final forum. So thank you very much, and if I could perhaps abuse your time and ask to give a wave and a smile and a cheer to toast all of your successes over the past 4 years, and of course to celebrate the path that remains in front of you. So thank you very much to all. It's a warm goodbye from Brussels and from all across Europe. And with that, we draw this PlastiCircle Final Forum to a close. Thank you.